Hello, dear students, civil and mechanical both. So, guys, as you know that we are conducting the PYQ series right now. We have already completed the previous year questions of civil of last 5 years, 2019 to 2023. This time, we are going to start with mechanical. From 2019 to 2023, all sets of mechanical. I guess 2019, 20, 21, 22, it is double set, forenoon and afternoon, and single set of 2023. That means 9 papers of mechanical we are going to solve now, me and the bright looking, the charming Dheeraj sir. Okay. And guys, as I told you earlier that civil PYQ of SOM is equally important for mechanical. So as here, mechanical PYQ is already more important or important for civil also. And I also told that it is more important for other branch because आप अपने PYQ तो करते ही हैं. You do your PYQ either in class or you have books. Okay, so looking for the other PYQ is much more important. Okay, so this is benefit for both. Complete PYQ, all questions of last 5 years of strength of material mechanical we are going to do in this session. One by one, we'll be taking the sessions. Let me directly go to Hisar, to Dheeraj sir. Dheeraj sir, your words, please.
Yes, thank you, sir. So, guys, as you already know that, sir have already told about this, and I'm telling you that more than 50 questions are there on strength of material from these 5 years. And guys, why recent years are going to be more important? Because as you know, whenever changes happen, they are happening gradually. So if you will find the level of question, the type of question, they are very much similar in the last 5 years, but they are very much different than the previous years. So it is how we need to know that what kind of question we are going to see in the GATE 2024 examination. So that's why last 5 years are always going to be most important part. That's why whenever we are having more time, we say that go for last 30 years. When less time, we say go for last 20 years. In the last, we say just revise last 5 years papers because they are going to be changed gradually. So last 5 years are becoming more important to us. So guys, now as you know that this is some detail about me. And after that, we are having a wonderful and important notification ready to today, 12 p.m. We are having a scholarship test. So if you want to get the scholarship up to 90% of the GATE preparation program, you can just go for this scholarship test at 12 p.m. It will be live. And guys, this is about the notification or sorry, detail about the last 5 years PYQ detail. So we have already completed PYQs of fluid mechanics and then thermal, then industrial, and then SOM civil is already over and mechanical today is going on. After that, the rest part of thermal applications will be there, then mechanics, then production, TOM, heat transfer. So in that way, you can see the dates. By 20th of June, we will complete all 5 years PYQs. So this is very important for you. Then my dear, on 30th June, this is going to be a workshop by Abhinav Negi sir, who is there with us as well. So you will attend this on 7 key factors that can transfer average student to the GATE topper. So sir will give you the proper guidelines as he's also experienced from last more than 11 years and he himself was a part of IIT. So definitely who better than him can guide you about the workshop. And these are the sessions of sir. This is related to the MTech is NIT at worth or not. And then second is average salaries after the MTech in civil engineering. So this is basically for civil branch. Okay. Moving further. So guys, for ISRO candidates who are preparing for ISRO 2023. So guys, for them, we are coming with the practice course from Monday onwards. Tomorrow will be the first class of strength of material I'll be taking. In every class, we are going to take 24 new questions, which are of the type which ISRO can ask. Okay. So guys, now we are moving further. This is my session. I'll be taking the best choices, top 20 choices for a mechanical students for NIT counseling based on the, you can say the previous year's records of placements and students' choices. Then guys, this is the Telegram channel link. The session PDF you will get on my channel, Mechanical by Dheeraj Sardana. And also you will get on the Abhinav Negi sir channel, that is Civil by Abhinav sir. So you can join the respective Telegram channels to get all the details and all the notifications. Now, without wasting your time, we are starting with the questions. And guys, this is the very first question we are starting with. Okay. Let us start the question, guys. So this is the very first question. Yes, guys. So this is the very first question. Consider the stress strain curve for an ideal elastic plastic strain hardening metal as shown in the figure. The metal was loaded in uniaxial tension starting from O, you can see that. Upon loading, the stress strain curve passes through initial yield point P and then strain hardens till Q. This is the strain hardening happening till Q, where the loading was stopped. From point Q, the specimen was unloaded to point R, where the stress is 0. If the same specimen is reloading again in the tension, the value of stress which the material will yield up to again. Yes, guys, please tell me what is the right answer for that. Yes. Arun, good morning. I am fine. Swapnil, Arun, please tell me what would be the answer for this question. So here we have loaded the material, then we have unloaded the material. If we are going to once again load the material, what you are thinking that what will happen? Will you get the yield strength equals to 180, equals to 210, or somewhere lying between this? Okay, Vineet is saying 210. Very good, Vineet. What about others? Yes, I want answer from all of you guys. Vineet said 210. If you don't have an idea, just try to give your opinion at least so that I can tell you what is the mistake in that. Yes, guys. Swapnil, Arun, everybody. Emmanuel, please tell me what would be the answer. Surya is saying 210. Very good, very good. So, guys, I would like to tell you whenever we are going to unload and once again load, because of strain hardening, the resistance of the material is getting increased. So that is why now whenever you are going to load the material again, the new yield strength will be 210. The similar question in the civil engineering we have done just 2 days back, where a question was there that whenever we are going for strain hardening, what kind of property changes happen. So there we have studied that yield strength increases. So my dear, now yield strength is not 180 but will become 210, and that practices are majorly done in the metal forming. Okay, but why I have taken this question here? Because similar questions have been coming in all the exams like ISRO, BARC. That's why. Okay, so the answer for this is going to be 210. So aspirant, I feel you got it. So guys, I would like to say this type of questions are more coming in mechanical because they are related to more metal forming. Okay, so if you are unable to answer, no issues. You have learned now. Very good, aspirant. Now this is the question where everybody can answer for both mechanical, civil, every student. Harshit, very good. So this question says a solid cube of side 1 meter. A solid cube of side 1 meter is kept at the room temperature of 32 degrees Celsius. The coefficient of linear thermal expansion of the cube material is this. Bulk modulus is this. The cube is constrained all around and heated uniformly to this temperature. Then the magnitude of volumetric stress induced due to heating is. So you need to find out the stress. Okay. No issues, Arun. That's why I already told you, na? Because there are like you have seen when sir was taking for you, sir also have said like shear stresses problems are not much coming for mechanical, shear flow problems are not coming much for mechanical. Likewise, stress strain diagram are coming less for civil. So 1 to 2 topics differences are there, rest 95% is same. Okay. Okay, here, very good, Vineet. You have given the right idea, but solve it. Okay. So we are having a solid cube like this. And as you know, the temperature is being increased. The temperature at room temperature 32 degrees Celsius, the coefficient of linear thermal expansion, alpha is mentioned. So they are saying if the cube is constrained all around. So cube is constrained all around with a volumetric stress of sigma. Why they are saying volumetric? They are all equal. Okay. It is similar to hydrostatic state of stress. Sigma compressive. And you can see temperature is being increased by 10 degrees Celsius. So I feel, you know, volumetric strain which can come is going to be 3 alpha delta T. And that will be stopped by these sigmas. So that will be equals to 1 minus 2 mu upon E into sigma xx plus sigma yy plus sigma zz will give you 3 sigma. So here you just need to find out the value of sigma. Okay. And if you don't know about E, then I would like to tell you that E is equals to 3K into 1 minus 2 mu. And you can see they have already mentioned you the bulk modulus. They have already mentioned you the value of Poisson ratio. So E can be found out by that. Try to solve it, guys. Yes, Vineet, Surya, and aspirant, Arun. Now everybody can do. This is the common type. Civil, mechanical, Axi, all three papers asking this type of question. And do like and share the session, guys. Very good. Vineet is saying the answer to be 60. What about others? What about others? Okay, Swapnil is saying 60. Very good. What about others? Arun, Surya, Emmanuel. Yes. Wonderful. Everybody have given. Harshit, very good. The answer will be 60 MPa. The answer is correct, my dear. 60 MPa is correct. Okay. Very good, guys. बहुत ही शानदार. Wonderful. So moving further to the next question, guys. This is from thin cylinder. Okay, this is from thin cylinder. A thin walled cylinder of radius R and thickness T open at both ends and fits snugly between two rigid walls. So initially the cylinder was open, but then it is surrounded by the rigid walls. Rigid walls are kept. So now both the ends becomes closed. Okay. But as you know, these are rigid walls. They are not going to move further. So you can say ambient condition as shown in the figure. So these are the things mentioned. Okay. Then what he is saying, the material of the cylinder has Young's modulus of E, Poisson ratio of mu, coefficient of thermal expansion alpha. What is the minimum rise in the temperature of the cylinder? Assume uniform cylinder temperature with no buckling of the cylinder required to prevent gas leakage if the cylinder has to store the gas at an internal pressure of P above the atmosphere. You need to find out the value of delta T, my dear. You need to find out the value of delta T. So you know that whenever we are talking about the circumferential stress, circumferential strain, it is given as sigma C by E minus mu times sigma L upon E. Then you also know that longitudinal strain, it is going to be sigma L upon E minus mu times sigma C upon E. I am giving you the formula, and you know the thermal strain is given by, it is given by alpha delta T. So you need to use these formulas. Okay. Let us see how many of you are going to give the right answer for this. And you know that the longitudinal stresses are going to be 0 because they have already mentioned it is open from both the ends. Rigid walls are there, so they will not create any longitudinal stress, because if the cylinder will be closed like this, then only longitudinal stresses will be coming because of these pressures. So rigid walls will not be creating any longitudinal stresses. So longitudinal stresses, you can keep it as 0. Okay. So guys, now try this. They have mentioned you the conditions here. So let us see how many of you are able to give the right answer. Longitude will be 0 as open from both. Yes, yes, yes. Okay, Vineet have given the answer to be D. What about others? Try to give answer, and guys, do like and share the session. Yes. So you know that if longitudinal stress is 0, this is going to be 0. And you know that they have mentioned that whatever the increase would be happening due to temperature, that should be balanced by the longitudinal strain. So you just need to equate these two things. You need to write mu times of sigma C by E, that is going to be equals to alpha delta T. Why I am writing them equal? Because delta longitudinal plus, epsilon longitudinal plus epsilon thermal, the summation is going to be 0. So this negative sign will become positive and they will be going on the other side, because total length cannot increase because it is closed by the rigid walls. Yes, solve it, guys. I want answer from every one of you here. Every one of you just need to equate these two things, and I feel you know sigma C is given as PR by 2T. 2T or T? PR by T. And sigma longitudinal is already 0. Just need to put the value and get the answer, guys. Sigma circumferential is PR by T or PD by 2T. You can use any of the formula and just get the answer. Vineet have given the answer as D. I'm waiting for Aspirant. I'm waiting for Harshit. I'm waiting for Swapnil. Swapnil have also given D. Harshit, Aspirant, Arun, solve it. Yes. I want the answer from your side. Okay, Arun have also given the answer as D. And guys, yes, your answer is correct. So guys, this is, you can feel it. The previous year's questions were not of that level. From last 5 years, a lot of change in the level of the question have been observed. So that is why this series was started. Abhinav sir said that we will be going for last 5 years because they are going to be very dynamic questions. Okay, so that's why this idea generated for you guys. And guys, now once again, the question is from stress strain diagram. Okay, here the loading and unloading response. I am telling you for this, this type of question are specifically coming for mechanical. I am already telling you. The loading and unloading response of a metal shown in the figure. The elastic and plastic strains corresponding to 200 MPa stress respectively are. So I am telling you what is going to happen. The loading happened like this. After that, unloading happened like this. So they are asking, they are saying this thing is 0.03, this thing is 0.01. So out of these two, one strain is going to be plastic, other strain is going to be elastic. One is going to be permanent, other is going to be temporary. That is what they are asking. For that, I will show you one very small example. Let us say we are having this PYQ book of BYJU'S exam prep. So if I am having this body, I am going to apply the load like this. When I will be applying the load like this, and let us say I'm holding it for some time like this, and when I am going to unload it. So after unloading, it is not going to stay there, neither it is coming back. It is coming somewhere in between. So whatever it is recovered is elastic, whatever it is having permanent is plastic. So let us see how many of you can give the right answer for this. Okay, already answered, answers are there. So answer for this is, you can see this one part is elastic because it is recovered 0.02, and this one is plastic because it was not recovered 0.01. So answer for this is going to be C. Very good, Jaya. Wonderful guys. Wonderful guys. Swapnil, very good. Vineet, very good. Harshit, very good. Surya, very good. Bahut badhiya. So guys, next question. After this question, Abhinav sir would be coming with some wonderful questions. This is 2021 1 mark question, set 1. A prismatic bar PQRST subjected to axial load as shown in the figure, the segment having maximum and minimum stresses. Every question is not difficult. This is very easy question. Every question is not difficult. This is very easy question. You can see that. Okay. तो वो दिल एकदम तोड़ते नहीं है आपका. They are giving you some easy question also so that मनोबल बना रहे. ठीक है. Yes. What would be the answer? You can see areas are equal for every member. So for the member where load is more, stress will be more. The load is less, stress will be less. Solve it, solve it. And guys, do like the session, and share the session, so that more and more students can join and you get the more feel of competition. Harshit D, Yash A. Okay. So I am considering this PQ bar as 1. QR bar as 2, RS bar as 3, ST bar as 4. So my dear, if you are going to make a section here, so you can find out the force in fourth section. It is going to be 25 plus 25 because away from the section is tensile. If you are taking the section here, you can write P33, method of section, 25 away, 20 towards, you will be having plus 5. Then if you are going to take the section here, then you can say P22 as 25 tensile, 20 compressive, 15 tensile, 40 minus 20 is 20. It is going to be plus 20. So you can see next, it is minus 10 is added here, P11. I am finding out the algebraic sum of all the forces either to the left or to the right hand side of the section. Okay. So when you will find out, for this section to the right hand side, 25, 20, remained 5. 15 plus 5, 20 minus 10, 10. So you can see these 4. You will find 4 member is having more load. and third member is having less load. So this will be having the maximum stress. This will be having the minimum stress. Okay. So in that way, the answer is ST and RS. ST and RS, not ST and PQ. ST and RS. D will be the right answer. I feel Arun, Aspirant, Swapnil, Surya, Vineet, all of you, Harshit, have given the right answer. Yash, I feel you got your mistake. Yes or no? So moving further, guys, to the next question. So now Abhinav sir will come for this question.
Yes, sir. Okay. So some wonderful questions have been done by the Master Blaster, Dheeraj sir. So let us do some more questions now. This is 2021 question. Okay. So we have changed a little bit strategy. Earlier, what we are doing, 2019 complete solutions. Then 2020 complete solutions. Then 2021 complete solutions. Then 2022 complete solutions. But in this SOM, what we have done that we are converting this into chapter wise. 2019, 20, 21, 22, all the solutions of the first chapter in a one go. Then 2019, 20, 21, 22, all the solutions of the second chapter, that is SFD in one go. Then 2019, 20, 21, 22, third chapter. And 2023, you already know that we have done. So we'll provide the link in the comment box. Okay, because 2023 we have already done. Arun, Swapnil, Harshit, okay, Aspirant, Swapnil, everybody, Surya is here, Vineet is here. A warm welcome to all of you guys. Okay. Now, let's move to the next question. This was asked in 2 marks and it deserves 2 marks question. What is here? That a right solid circular cone. What is right solid circular cone? That is symmetric about y-axis, like this. Okay. So this cone is not something like this. That is symmetric in vertical direction. So this is the cone. Okay. And in this cone, what is happening? Let us see here that height is h, base radius is r. This height is h, this base radius is r. Okay. And what is there? The cone is made of material with specific weight W. The unit weight lambda we generally say that is W. Unit weight is equal to W. Okay. आगे क्या दे रखा है? Let us. Oh, Suraj sir is also here. The champion. Suraj sir is also here. Okay. So welcome, Suraj sir. Okay, everybody, guys, please welcome. Put a heart sign to Suraj sir. Okay. Now modulus of elasticity is E, and self weight is deflection due to self weight is asked. Now, if not, see, unless mentioned in SOM, we everything considered to be weightless. Okay. Unless mentioned in SOM, we consider everything to be weightless. So here it is saying that weight is there, unit weight is given. So now, guys, please understand the whole process that I'm telling you. After that, I will ask you that have you understood? You mostly will say yes. Yes, we understood. Then in the same steps, what I will be doing, I'll be asking a doubt to you. You will not reply. I am an astrologer, na? I am astrologer. I am predicting. I will solve. I will solve. I will say any doubt. You will say no. Most of you say no. Then I will ask a doubt from the same steps. And you will not, most of you will not reply. I guess so. If you reply, and if I was wrong, I'll be more than happy. Okay. Now, take an element at an x distance. Here area is changing. Of course, the weight is changing at a different section. Like my legs are taking whole body weight. But my, what is this? Kamar. This is like kamra. So much fat I am. So this kamar is taking this much weight. This neck is taking only this much weight. But my legs are taking whole body's weight. Okay, similarly, this is taking the whole cone's weight. This is taking only this part weight. Okay, similarly, this is taking only this part weight. Okay, so weight is changing, area is changing. So we have to do integration. Yeah, we cannot directly apply delta is equal to PL by E. We cannot directly apply delta is equal to PL by E. Okay. Now, here, at this section, either we have to see from top or bottom, your choice. Your choice. So let us see the weight from the top. Now here one doubt. If I ask you, I have take either see from top and out or top and bottom. So I am seeing from top. So my doubt is, मैं बता नहीं रहा. First of all, my doubt. Okay, thank you, Sumit. Now my doubt is that is this yellow weight and what color I choose? ऐसा होता था ना बचपन में ऐसे करके. What color do you choose? Okay. If I take this yellow one and if I take this red one, is both weight same? Red one is more, na? Red one is more, depending upon this cross section is somewhere in the mid. Red one is more. So how I can say that it will be either you take see from top or bottom, both will be same. Can you please let me know? Can you please tell me? Can you please tell me how this is possible? I am saying that either see from top and bottom. So from yellow and red, how it will be same? How it will be same, yellow and red? Tell me. Tell me please. How this will be same? Yellow and red. How that will be same? Yellow and red. Let me tell you, guys, suppose it is around mid. This is yellow, and this is red. So you will be saying red is most. And let me check that anybody if you have given the comments. Mid par hai isliye. Good morning. Okay. Now, why it is same? Because suppose this weight is 3, this yellow weight is 3 kg. This red weight is 5 kg. This red weight is suppose 5 kg. So what will be the reaction? You are not considering reaction 8. So at this section, if you are seeing from top, 3 is coming inside compression. So from top it is 3 compression. And at this section, this blue section, if you are seeing from bottom, 5 going here and 8 is like here. So from bottom also 3 compression. Give me beautiful yes or no and the comment box. I'm saying it is at mid na. So both are not same. Yellow will be less weight, red will be more weight. So either you say from top and bottom, this is the concept na. So from top it is less and red is more. So you think like this. No, from bottom also it will be same because 5 minus 8 is again 3. Give me yes or no in the comment box. Beautiful concept. Not beautiful concept, but these students generally don't think. Okay, now my still challenge is there. My challenge is still there. That I will solve this again. I will say any doubt, most of you say no. And then I'll ask a doubt from the steps. You will not be able to answer. I predict if you are able to answer, I'll be more than happy to being wrong. See now. So delta is equal to PL by AE. As the weight is changing at every section, and area is also changing. So we have to integrate. We have to take this very small element of dx length, and this very small deflection d delta is equal to PL by AE. Okay. So L is dx. Area of that section is suppose AX. Okay. Into E. Area of that section is suppose AX. Okay, what is force? Either see from top and bottom, it is same. So what is this yellow? What is this yellow force? This. What is this yellow? What is this yellow? Volume into density. So what is volume? 1 by 3 pi radius at that section rx square into height, that is x. What is pi rx square? 1 by 3 pi rx square can be written as ax. Pi r square can be written as ax. So 1 by 3 ax into x. This is volume into weight. This weight is actual density. So density into volume is weight. So this is 1 by 3 area at that section into x into w. So ax cancelled, ax cancelled. So d delta is equal to 1 by 3 into E common x square, x dx integration. Sorry, w is also there. ax cancel, w by 3, x square by 2, x square by 2. This is the integration. So integration will be delta. Now integrate, we want where the vertical deflection at mid height. The vertical deflection at mid height is asked. The vertical deflection here at mid height is asked. So at mid height, delta will be integration of d delta from h by 2 to h mid height. From mid height h by 2 to h is equal to w by 3e x square, but 2 is also taken common here. 1 by 2 x square. It will be h square minus h square by 4. It will be 3h square by 4. So it will be 3 by 8. 3 by 8. Please check. कुछ calculation mistake हुआ है. It will no 1 by 8. Okay, 3 cancelled. It will be wh square by 8e. That is option number D. Now my doubt. Ready? Everybody please tell me in the comment box. Ready now for my doubt? First of all, give me yes or no. Have you understood this? Any doubt? Any doubt? Any doubt? Give me yes or no. Give me yes or no. Give me yes or no. Come on. Arun, Vineet, Swapnil, Harshit, everybody who is in the comment box, please tell me. No doubt. No doubt. Sumit, okay. Now, yeah, Arun ने पूछ लिया. Okay, बाकियों को तो doubt नहीं था. Arun ने पूछ लिया. Arun has asked that out. Good, Arun from Allahabad. Now my doubt is to other students who have not mentioned any doubt except Arun, because Arun has asked the doubt. So why we have taken from h by 2h, not 0 to h by 2? Why h by 2 to h, not 0 to h by 2? Arun, except Arun, everybody, I want this because you have not asked out. Because you have not asked out. Because you have not asked out. Why 0 to, why h by 2h, not 0 to h by 2? This is my doubt. Now see guys, suppose now this is a thing and this is 0, this is h by 2, this is h. Now whatever is the deformation of this shaded region, is the deformation of this point. Is the deformation, let this be A, let this be A, this be B. So delta AB, whatever will be equal to delta B, because A is fixed. Because delta A is 0. Because delta A is 0, A will not be changing. So whatever is the change AB, that every change will be in the B portion. But whatever change in the delta BC, we can't say delta B because BC is also changing. Have you understood now? Whatever the change here, since this top bottom portion is not changing, h by 2 to h, this portion is not changing. So whatever change in this will be changed at the mid depth, h by 2. But same cannot be done here because here mid depth is also changed, this is also changed. Give me a beautiful heart sign on the comment box for this beautiful concept. Okay, and just sir has showing you the workbook. Okay, that whole workbook for civil, mechanical and all branches that has been developed under the guidance of Virat sir. Okay. Okay, understood? Okay. Now let's do this question. This was asked in 2021. Again, the question is of 2 marks. And yes, this can be asked in a little 1.5 marks also, but 1.5 marks is not in the paper. So it is asked in 2 marks. But yes, this question was worth of 2 marks. Okay. Now, guys, if E and mu is given, so what is the value of K? E is given in the question. This is E. This is mu. So from here, we can find out the value of K. From here, we can find out the value of K, and the value of K 1 minus 2 mu hoga kya? From here, the value of this is K is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.67. Please check. This is the value of K if you find it in megapascal. Okay. So this is the first step. Now second step, K से क्या करेंगे? K is equal to sigma by volumetric strain. So volumetric strain is equal to sigma by K. So sigma is known. Sigma is this hydrostatic pressure. K is known. So from here, volumetric strain is known. From here, volumetric strain is known. So volumetric strain is delta V by B. And what is the volumetric strain coming from here? Let me just check it. The volumetric strain coming from here is 1.5 into 10 to the power minus 3. Okay, volume is known. Volume is known. Okay, 200 into 200 into 200. So from here, delta V can be find out because volume is known. So delta V is 12,000 meter cube. 12,000 mm cube. Now the new V is equal to, earlier V was 200 cube minus 1200 cube. Sorry, 1200 is the volume itself. 1200 is the volume itself. 12,000. So new earlier volume is 200 cube, and from this to 200 cube, 12,000 is reduced. So now new volume is 7988000. Now new volume is 79. Okay, guys, 88000 mm cube. 79 double कहाँ गया यार, मोबाइल ही बंद हो जाता है तब तक तो 8800. Okay, so A will be cube root of this. So A will be, side will be cube root of this. So that will be 199. New A 199.899. 199.899. So they have asked the change. The side of the block is reduced by, that is 200 minus this. Earlier it was 200, now it is this. So that will be 0.010. 0.010 mm. That is the answer. Give me yes or no. E ki power 5. Okay. Okay. Give me yes or no. Have you understood the concept? Okay, please fast. Now this is the question, and they are asking the magnitude of the reaction at joint C. What is the reaction here? RC. Guys, at hinge, what is the bending moment? Bending moment at B is equal to 0. See from right hand side, guys, keep sharing the session. From right hand side, it is RC into 4. From right side, it is RC into 4. And one is this 10 into 4, 40 acting at 2. So 40 into 2 is equal to 0. So RC value 80 by 4 will be equal to 20. Will be equal to 20 kilonewton. Okay. Give me yes or no. Any doubt? Now let's go to the bending stress. Now let's go to the bending stress. Okay. So in bending stress, what is the question? The question is that consider an elastic state beam, and this was of length L is equal to 10 pi. Okay. So length is equal to 10 pi. This L is equal to 10 pi. Now this length is made into form of a circle. This length is bent into form of a circle, and if I tell you the cross section of this, so cross section of this is a square of side 5 mm. Cross section of this is a square of side 5 mm. Okay. Now it is bent in such a way that two ends meet. This end and this end meets, bent in a form of a circle. That thing is bent in a form of a circle. And what is asked? I guess they will be asking the maximum stress, the maximum tensile bending stress. Okay. So suppose this is a rectangular plate. This is a rectangular plate. Length will tell pi. This is bent in a form of circle. This is bent in a form of a circle. Earlier it was rectangle. Like this. Like this. Now, what will be the radius? So guys, now the circumference 2 pi r is equal to actually length. Circumference is equal to length. So what is the value of r? So pi to pi, r is equal to 5 meter. R is equal to 5 meter. And here movement is not given. So instead of using sigma by y is equal to m by I, we will be using E by R because other terms are given. Now sigma is equal to E by R. Okay, sigma max will be, sorry, E by R into Y. Sigma max will be E by R into Y max. Now tell me, R value is given? Yes, sir, R is given. Young's modulus is given? Young's modulus is given. What is Y max? From here, neutral axis. What is Y max? Y max is equal to 2.5. All values are given. Now you can do in proper units. Excellent, Anubhav. Now you can do in proper units. Y max is known, everything is known. So from here, Y max is E is there, R is there, everything. Y max is 0.2. This is 5 mm, na? Section of side is equal to 5 mm. Okay, so what is the answer coming? Can you please let me know? Can you please let me know, everybody? 100 megapascal? 100 megapascal. Simple answer. Okay. Now this is the question. After this, Dheeraj, the master blaster is coming. A wire of circular cross section of diameter 1 meter is bent into a circular arc of radius 1 meter. By applying a pure bending movement, it ends. The young same question, same concept. Guys, what is happening? That this is the wire. This is the wire. This wire has diameter how much? 1 mm. This diameter has diameter how much? 1 mm. This red diameter. This is 1 mm. Now this is bent in a circle like this. Now this wire is bent in a circle. Okay. Of radius 1 meter. This radius now, this loop's radius. This radius is now 1 meter. Okay. So this wire radius is very small. Wire radius is 1 mm. But now it is bent in a circle. Okay, that radius is now whatever 1 meter कितना दे रखा है 1 meter. एक तो मेरे को यार ये बोर्ड पे ना तुम भी कभी पढ़ाने आओगे, if you also come to बुक में अच्छे से रीडिंग दिख जाती है, इसमें ऐसे करके पूरा देखना पड़ता है, कहाँ है इतना बड़ा देखना है भाई, इधर से इधर 3 फीट 4 फीट जितने का भी है. Okay, so the maximum tensile stress, again same concept, sigma by y is equal to m by r. So this is E into y max. E is known. What is radius? Radius is this. Diameter is this. So that wire, the red wire I just show you was like this. That has diameter. That has diameter. How much? 1 mm. 1 mm. So what is y max? What is y max? Half of this 0.5 mm. Okay. So this red wire is bent in the form of a circle whose radius was 1 meter. Now putting y max values 0.5, E and R is given. So what is the sigma max coming? What is the maximum coming? Only civil engineering का जलवा है, सबका जलवा है भाई, सबका जलवा है. मैं खुद जब अपने कॉलेज में एडमिशन दिया था तो उस समय फर्स्ट ऑप्शन मैकेनिकल भरा था मैं. ओके, सबका जलवा है. ओके, so guys, how many of you are from civil? Can you, civil and mechanical, please write your branches. How many of you are from civil? How many are from mechanical? Please write down your branches, please, on the comment section. Everybody. Anubhav civil. Anubhav, you were yesterday session. Oh, बीच में आप आए थे ना शायद. Sumit mechanical. So Swapnil civil. Arun. Anubhav, I guess yesterday in between you have come, na? Okay. Okay, 1 minute. Okay. Okay. So Dheeraj sir has also come from mechanical. He is education from mechanical. Jitin from mechanical. Yes sir, but okay, okay, Anubhav, good. So Anubhav, आप भी मेरे को मेल कर देना, मैं PDF दे दूंगा abhinav.neki@byju's.com पर. So Dheeraj sir.
जी सर.
मैंने आपका बहुत समय ले लिया.
अरे सर, आप ही का है टाइम. I was looking at the wonderful explanation you were giving, sir.
पर आप मेरे समय वंडरफुल एक्सप्रेशन देते हैं क्योंकि आपको अपने वाले क्वेश्चन पता है। मैं आपके पढ़ाते हुए नहीं देखता हूँ कि मैं अपने वाले का आंसर देखता रहता हूँ आगे वाले का। दैट मीन्स यू आर सुपर डुपर इंटेलिजेंट।
अरे सर।
क्योंकि आप अभी पढ़ाएंगे, मैं आगे वाले क्वेश्चन का रट्टा मारूंगा।
सर आप ऐसे ही हमेशा मतलब बिफोर विदाउट प्रिपरेशन ही आगे करते हैं हमेशा आप।
नहीं 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 सर, मजा सर। ओके, मैं कैमरा ऑफ करता हूँ, आप मचा दीजिए।
थैंक यू सर।
थैंक यू सर।
So guys, sir have given some wonderful explanation of the questions. I was also looking at that. Really amazing it was. So now let us move to some of the other questions. Okay. This question is related to an overhanging beam PQR. You can see this PQR is a beam subjected to uniformly distributed load of 20 kilonewton per meter. This is the loading, and this is shown in the figure. This is 2 meter and this is 1 meter. So total 3 meter is there. Cross section is given as 24 mm width, 100 mm depth. So guys, they are asking you the maximum bending stress developed in the beam. So I feel everybody is aware that when we are talking about the maximum bending stress, it is always given by M upon ZNA. But if you want to talk about the maximum, we need to take the maximum bending moment also into the consideration. So first of all, for this given beam, our target is to find out the maximum value of bending moment. Once we get the maximum value of bending moment, we can find out the bending stress, because Z we know that it is going to be BD square by 6. Okay. So we just need to find out the maximum bending moment for this loading. So for that, first of all, we will take the support reaction here and support reaction here. This is, let us say, RP. This is, let us say, RQ. For that, we need to make the equations. You know, first equilibrium equation is summation Fy0, which will give us Rp plus Rq is equals to 20 into 3, that is 60. Okay, I am taking in the kilonewton format. You also try as per the information given. Okay, I feel you would be aware how to do that. First, you need to find out the support reactions. Okay, so then we will see what else can be done. Then we will go for the summation moment at Q to be 0. Because it is hinge point, about this moment is going to be 0. So you know that this RP is creating clockwise. So we will say RP into 2. And this complete UDL can be assumed to be present at its centroid. And centroid of 3 will be at 0.5 meter from here. And that will be creating anti-clockwise. So this is going to be minus 20 into how much distance? It is 3 meter, and it is at how much distance of Q? It is 0.5. So you will put it to 0, you will get RP here, and putting this value of RP, you will get RQ here. Can you give me the value of RP and RQ? Then I will go for the further solution. Can you give me? Yes, Anubhav, Vijay. Yes, yes, yes. Education Hub, Jitin, CAD. Okay, Arun, Sumit, Swapnil. Wonderful, wonderful. I feel aspirant is not there now. RP is coming out to be 15 kilonewton. RQ is going to be 25 kilonewton. Yes. 15 and 45. Sorry, 45. Yes, very good. All of you, very good. So 15 kilonewton and 45 kilonewton are the values of RP and RQ. Very good, Surya. Wonderful, dear. So 15 and 45, you are getting the values. Hai na? So obviously, when the total load ka centroid that is coming near to Q, so more reaction will be coming at Q, that is for sure. Now, my dear, what we need to do, I am showing you that we are having this as RP, this as RQ, and this was the UDL. This is the case. Now, my dear, we need to find out the maximum bending moment. So first, we will be taking a section XX at a distance of X. So when you will be writing the bending moment equation MXX, you will write it as RP into X, creating clockwise to the left hand side, and UDL will create anti-clockwise. So minus W into X into X. W into X is load, X by 2 is the centroid distance. So RP value you have calculated as what? 15. So it is 15X. Minus what is W? W is 20. 20 into X square by 2. So 2 will get cancel out. You will get the equation to be 15x minus 10x square. Now, if you want to find out, you have taken x from here. You will find out where bending moment is going to be maximum. For that, dm by dx, you will put it to be 0. So it is 15 minus 20x is equals to 0. So x will be coming out to be what? It is 15 by 20. It will be coming out to be 3 by 4. It will be coming out to be 0.75. So we get to know that where we will get the maximum bending moment at a distance of 0.75 meter. And that 0.75 meter, if I put in this equation, I will get the maximum value of moment. So when you will be putting this value, my dear, that is equals to 15 into 0.75 minus 10 into 0.75 ka square. That will give you the maximum value of bending moment. Anybody have calculated? Surya, Arun, Jitin, Anubhav, Vijay, anybody? Aspirant, anybody? So when you will solve this value, it will be coming out to be 5.625. 5.625 kilonewton. This was a lengthy question of 2 marks. Very good, Anubhav, very good, everyone. So when you are getting 5.625, now you just need to put this value here and you will get the bending stress maximum value. This is the NAT question. 5.625. It is kilonewton, so 10 to the power 3 divided by width is 24, depth is 100. BD square 100 ka square by 6. This will give you the final answer. So Surya, Arun, Swapnil, wonderful guys. Anubhav, Jitin, very good guys. So just solve it and give the answer. So we are requiring the bending stress value. I already calculated for you. So I feel you guys are enjoying the session the way sir was explaining you the cone problem. You will not get that kind of solution, that kind of explanation at any other place. Okay. So the way of explanation will give you a confidence for the similar questions as well. So we are not only here to mug up the last 5 years question solution, but to make you prepare for the similar questions. So that idea, once I had, I was very happy to get that, yes, last 5 years question, when sir said, we said, yes, it is going to be very beneficial for the students. And so is your response, guys. Wonderful. So the answer will be coming as 140.6 MPa. 140.6 MPa. Okay. So this is 10 to the power 3. This is coming into Newton per mm square. 140.6 are we getting? Yes. Okay, 0.14 we are getting. 0.14. I have not calculated. I have calculated only till this point. I thought ki after that we can do. So it is going to be 5625 into this. So 5625 divided by this. So I feel, yes, 0.140 would be coming. But it's fine. I feel you can do that much. That's great. Moving to the next question, guys. Next question is from GATE 2019 for 1 mark. And now we are coming into the deflection. So retort question. A cylindrical rod of diameter 10 mm, length 1 meter, fixed at one end, other end is twisted by an angle of 10 degree. You know, theta, whenever you write, this is 10 degree. Without sine and cos, we always put in the radians. Divided by pi 180. By applying a torque, if the maximum shear strain in the rod is given to us. I feel you know, tau by r, which tau? Maximum tau. T by j, g theta by L. You know that. Okay, sorry. Yes, that was the mistake actually. It will be coming out to be 10 to the power 6 because it is Newton meter. So we have converted into Newton mm. Very good, Anubhav. You have found out the mistake I have done. It is 10 to the power 6 because Newton meter was the unit. So I have converted first kilonewton into Newton, then meter into mm. So when you will go for these two transition, 10 to the power 6 will come. So then this answer is correct. Wonderful. Thanks, Anubhav. Okay, next. So guys, now what we are going to do? Tau max by r, T by J, G theta by L. You know that if we are going to write it in this way, tau max by r is G theta by L. If I just write it in this way, tau max by G is equals to r theta by L. I feel everybody understood that this tau max by G is nothing but the shear strain phi or gamma. So that can be found out by r theta by L. Now, my dear, you can see this is given length 1 meter. Diameter is given. Theta is given to us. Put the value, get the answer. 1 mark, very easy question. Torsion question. After this, we are going to enter into the your favorite SFD-BMD deflection part, that is favorite of civil peoples, where you must have seen many times sir have taken the shortest trick, where sir is going to tell you everything in 30 minutes, 1 hour, how to tackle with SFD-BMD problem. So we are also going to do torsion like that also. So every chapter, whenever you are having good command, you will be able to solve it very nicely. Yes, Arun, Vijaya, Anubhav. Okay, Surya have given the answer 0.87. That is correct. 0.872 is correct. Because when you will be equating it with P into 10 to the power minus 3, P will be coming out to be this. Surya, very good, dear. You are doing very nicely. Wonderful. Anubhav, Arun, everyone. Have you done it, guys? Please tell me that. Very good, Swapnil. Wonderful, Swapnil. Very good. Moving to the next question, guys. Now we are entering into the deflection part, deflection of beams. Okay, deflection of beams is coming more for civil peoples. For civil, 1 to 2 questions are compulsorily coming from that topic. But from mechanical, either SFD-BMD or deflection, 1 question is coming from both. So in mechanical, actually equal weightage is given to all the things like maybe simple stresses, 1 question will come, bending torsion, 1 question will come, SFD-BMD deflection, 1 question will come, strain energy, 1 question will come, thin pressure vessel column, 1 question will come. So equal weightage is there and more weightage is there. 8 to 10 marks is coming for SOM. So a cantilever beam having square cross section of side A is subjected to an end load. Okay. If A is increased by 90%, the tip deflection decreases approximately by. You already know if we are having a cantilever beam like this, and we are going to apply a load P like this, and the load they are saying, because of which deflection is coming out to be PL cube upon 3EI. You can say deflection is directly proportional to 1 upon I, and I will be nothing but A4 by 12. So that is the case. So you are said that 19% is increase of A. Then by how much percent deflection will get reduced? Yes, solve it. Solve it, guys. Options are there in front of you. 19%, 29%, 41% or 50%. You can do in this way. Y1 by Y2 can be written as I2 by I1. I2 is after 19% increase, A dash will be 1.19A. But they are saying that, yes, tip deflection decrement you need to find out. So I2 will be A ki power 4, 1.19A to the power 4 by 12 divided by A4 by 12. So from here you can find out that Y2 will be how much percent of Y1. Then you can find out the percentage decrease as Y1 minus Y2 by Y1 into 100. This will give you the answer. Surya is saying D, Anubhav is saying D. Yes, I'm waiting for the answer of Swapnil, Arun. Arun is also saying 50, very good. Yes, Swapnil, what do you say? All other students, Vijay, who are there in the class. Very good. So you will be getting 50%. Because what you will find is, you will find that y2, okay, the value I am telling you, you will get the value of y2 as 0.5 times of y1. Okay, so that is why 50%. Very good, guys. Moving further to the next question. Once again from 2019. This time a horizontal cantilever beam of circular cross-section length 1 meter and EI this much subjected to applied load at free end as shown in the figure. The magnitude of the vertical deflection of the free end will be. So I feel you are aware of the formula for this. When you are applying a bending moment like this, deflection will be upward. And if you are going to find out this deflection, this will be ml square upon 2EI. This is the formula. You know everything. Just put the value, get the answer. Very easy question. Yes, very good, Arun. So this question, my dear everyone, I'm expecting everyone to answer it. Surya, Swapnil, Arun, Anubhav. Wonderful, guys. So dear, it is always an advantage to go for inter-branch question. I always advise even to mechanical peoples that civil and XC questions will be more helpful because they are going to be repeated in your paper. After me, when Abhinav sir will come, that is a question which was repeated in mechanical from XC and civil. That question was already asked many times in XC and civil and it repeated in mechanical for the first time in 2019. Okay. So that's why I want to say that it is very important to go for last 5 years PYQs. So answer will be 2.5 mm. Everyone have given the answer correctly. Wonderful. Moving further, guys, and I feel this is the last question from my side. Then Abhinav sir will come. Okay. So if you see this question, my dear, once again, a prismatic straight elastic cantilever beam is subjected to a linearly distributed transverse load as shown in the figure. So you can say simply, this is a cantilever beam on which UVL is acting like this. Okay. So my dear, what you need to do, you need to find out the magnitude of maximum deflection. I feel this everybody would be remembering because in the table, we remember the result. For this case, if you will be finding out the deflection at A, you will be getting minus WL4 upon what? Everybody remember that. Very good. Surya, 30 EI. Okay. And when you will find out the theta A for that, it will be W L cube upon 24 EI. Don't worry. I am going to show you the solution as well if you want. Don't worry for that. So we are having this. Everybody remember that we always remember this table so that we can very easily do that. So if this is A, this is B, you are going to write down equation at section XX. So you write the equation at section XX as EI d square y by dx square is equals to mxx. Mxx is nothing but, you can see, this is the section, triangle is the load. So we can assume the area of triangle acting at centroid. So if this distance is x, we will be having Wx by L acting at x by 3. Everybody know that? Because if you take this triangle, total load is W here, maximum. So here will be Wx by L. So you can write it as moment is this into this. So this is going to create Hogging minus Wx by L half into x. This is the area acting at centroid x by 3. So when you will be going for the integration once, you will get dy by dx EI. First integration, you will go for minus 1 by 2 Wx cube by 6L dx. After that, you will go for the second integration, EI into y, double integration. And when you will go for double integration, here one integration constant will come as we are going with indefinite integration. then minus 1 by 6 wx cube by L into dx plus c1x plus c2, because indefinite integration. This equation, when you will be solving, you will get the value of theta and y. Anybody wants me to do the complete derivation? Because I know that everybody would be remembering these results from UDL to UVL. Anybody want me to do the complete derivation? Yes, Harshit, Swapnil, Arun, Anubhav. Very good, guys. Anybody? Yes. Okay, fine. So if anybody wants, then I will go for the complete. Otherwise, I know that you have remembered the table. So if the similar way they will be asking you for UDL, you would be remembering deflection will be WL4 upon what? ATI? Yes. So similarly, the cases are coming. Fine, Anubhav. So now Abhinav sir will come from this question, and this is the question I was saying that in civil and Axi, it was asked many times, and for the first time in 2020, it came for mechanical. Likewise, I can show you many questions repeated from Axi and mechanical in civil as well. So, sir, am I right?
Bilkul, sir. You are always right. So this question, sir, you have done, na? Okay. So now, okay. Now I will be doing this one, guys. Okay. So let us draw the free body diagram now. Whenever, guys, spring question will be coming, you have to do this almost every time. This is P. This P load wants to push this beam downward like this, but the spring will be provided the upward reaction. Let the upward reaction be R, and if the upward reaction is R, then the spring will be having the R reaction downward. I already told you yesterday that what I do, what I follow to make the free body diagram. I assume that that part is Abhinav Negi. Suppose I want to make the free body diagram of beam. So I assume that Abhinav Negi is beam. So if Abhinav Negi, somebody is applying P load and beneath me there is spring, the spring is pushing me upward. That is how I have drawn this R. Literally I assume this. So suppose I want to draw the free body diagram of spring. So I assume Abhinav Negi is a spring. So beam is pushing me downward. If I'm a spring, so R downward. Like this I do. Now this, ye to joint hi rahega. This is joint. Okay, this is joint. So deflection of this point and this point will be same because they are joint. Okay. It is not like it is, if this will be going something like this. If this is going something like this, okay, then this will be spring like this. After this, I'll tell you a trick of deflection. They are not 100% applicable everywhere. That trick is 100%. The trick is correct, but yes, it can be applicable in few areas. Now, suppose deflection of this point is P minus L cube. P L cube by 3 EI, and due to R, this is R. So instead of P, I can write here P minus R. Instead of P, I can write here P minus R. P minus R L cube by 3 EI. And deflection of this point is R by K. Both will be same. Both will be same. From here, you can find out the value of R in terms of P. From here, you can find out the value of R in terms of P. Now, let me check that how much it was coming when we are finding R in terms of P. Then this is coming to be, please check. R is coming to be, okay, 1 by K plus L cube by 3I is equal to PL cube. No. Okay, guys, whatever the R is coming, leave that. You can do it from here. Then deflection will be either you put here or here, anywhere. Deflection will be R by K. Either you put here, both are equal, it will be same. So from here, you will be getting the C option. Have you understood the concept? Kya? Principle of superposition भी कह सकते हैं इस वाले पार्ट के लिए, पर ओवरऑल तो वो एक जस्टिफिकेबल थिंग है ना, ओवरऑल तो एक वो ऑब्वियस थिंग है. Okay, putting the value of R here, we get the C option. Now next question, everyone, please see. what is here, that a cantilever beam with uniform flexural rigidity like this, okay, is loaded at a concentrated force at the free end. So here is the free end. The area of the bending moment diagram corresponding to full length of the beam is 1000 Newton per meter square. This area, this is not the M by EI diagram. This is the M by M diagram. This total area is 10,000 Newton meter square. 10,000 Newton meter square. This is the complete area. Okay, the magnitude of the slope of the beam at the free end. The magnitude of slope of the beam at the free end. So what is theta B minus theta A? Area movement first theorem is equal to area of M by EI diagram. Correct? This is equal to area of M by EI diagram. Please tell me fast. Yes or no? जल्दी बताओ यार, कहाँ गए कमेंट आपके? जल्दी बताओ. Yes or no? Area of M by EI diagram. चलो यहां से बताना कितना आया. M by EI कर दो. M by EI कर दो फटाफट से. कैलकुलेशन कहाँ की थी मैंने? एरिया ऑफ M by EI कर दो और वैल्यू बता दो मेरे को भाई. भाई लोग मेरे को वैल्यू बता दो. एरिया उसको M by EI से डिवाइड करो and tell me the value. That is, and theta A will be 0. This is M diagram area is 10,000. कहाँ गया? 10 like this divided by EI. EI value is given क्या? EI value is given 200 into 10 की power minus 6. EI value is given as 200 into 10 की power 6. From here, theta is coming 15 to 10 की power minus 6 radians. Theta B is equal to 50 into 10 की power minus 6 radians, but it is as micro, so it will be 50. It will be 50. Any doubt? Give me yes or no. Any doubt? Give me yes or no. Okay. Okay. 5 नहीं यार 50. 5 नहीं 50 भाई. 5 नहीं 50. 50 50 कैसे 5 आ रहा है बताना जरा. कैसे 5 आ रहा है आपका? EI की वैल्यू उधर डालो, है ना. यहां से जो वैल्यू आता है वो किसमें आता है? फ्रॉम दीज काइंड ऑफ फॉर्मूलाज PL स्क्वायर बाय व्हाटएवर. What we got the values? We got the values in terms of radians. Okay, 50 आ गया. 5 कैसे आ रहा है? अभिनव का भी, अरुण का भी, स्वप्निल का भी 5. चलो करते हैं भाई, करते हैं. अब तुम ऐसे बूढ़े आदमी से ये भी करवाओगे भाई. अब तुम बूढ़े आदमी से कैलकुलेशन भी कराओगे. 10,000 by EI. So 10,000 by EI. 10,000 means 10 की power 4 by EI. 200 into 10 की power 6. So this will be 1 by 200 into 10 की power 2. So 2 into 10 की power 4. चेक करना करेक्ट है क्या? चेक करना करेक्ट है क्या? If I multiply 100 both sides, 100 both sides here and here, so 100 by 250 into 10, denominator will be 10 की power 6. It will be 10 की power minus 6. करेक्ट तो है. 50 आएगा यार. 50 आएगा. Okay, good, good, good. Next question. Oh, little bit good one. Okay, चलो मजा आएगा इसको करने में. इसको करने में मजा आएगा. और same kind of questions as Dheeraj sir has told you have found in the civil PYQ also, and not we are considering the PYQ of here last 5 years, and that was from 1995 to 2000. Those questions were also last 5 years. So even in those 5 years also, they are mixing the questions of SOM and mechanical and XZ very frequently, not the data but the concept. Okay, that question was also of last 5 years. एक तो ये AC so much chilled कर रहा है, ऐसी Greenland बन जा रहा है यहाँ पे. Okay, so there are two parts. One is this yellow and one is this orange. Now I will make the free body diagram. मेरे को आता ही क्या है, free body diagram बनाना ही आता है. This is the orange and this is the yellow. Now here the F force is coming. Let this F force be Pn. Okay, let this force F be Pn. Okay, so here is how much? Pn for balancing And what is the moment? This length is L. So it is applying Pn into L. So this will be applying Pn into L here. Internal force always equal in magnitude opposite direction. So that Pn will go here. Pn. And here Pn clockwise. So here, whoa, this is rotating it. This is rotating it clockwise. So here it is anti-clockwise. So here it is anti-clockwise. So here this F value will be no. This is anti-clockwise there. So here this is rotating it like this, है ना? So this is clockwise. So internal force equal and opposite. So this is here in this direction. So this will be opposite. This will be opposite, है ना? This will be Pn into L like this. Okay, and here it is fixed. Now we will be doing what we have to find deflection, horizontal deflection. It is horizontal load. So according to strain energy, this will give del U by del P in the direction of load only. So load itself is horizontal. So that del U by del P will be giving the horizontal deflection only. The del U by del P is giving the horizontal deflection. Guys, you know, remember this del is equal to del U by del Pn. This formula gives the direction deflection at the where Pn is acting. Okay, and this gives in the direction of Pn. That means horizontal. Pn we have taken is equal to F na. So this we have to whatever what I told you. Abhinav Negi method of strain energy, that is obviously universal method. Mx, whatever you have written here, differentiate with respect to Pn into dx by EI. I hope you remember this. Now you have to apply this for the whole beam, not only for the orange part. You have to apply this for whole beam. Let us first of all do this for orange part. What is the mx at any distance? Pn into x. Okay. Now whatever written here, differentiate with respect to Pn. So differentiate with respect to Pn will be x dx upon EI. And this is varying from 0 to L. Now for this yellow part plus, okay, yellow part is again from 0 to L. Okay, at any section, what is the bending moment? And this Pn is not applying any bending moment. Bending moment is due to PNL. Okay, the bending moment is due to Pn into L. Whatever written here, differentiate with respect to Pn. L dx upon EI. Now here this step is done. Now we can write the original values, that is Pn is equal to F. Now we can write the original values. So this is equal to, everybody please see here, Pn is equal to F. Now we can put the original values. This is F, this is F by EI, and this will be x square by 2. So put 2 here. X square integration will be L square. So FL square by 2i, this orange term. Now all yellow term, this is Pn is equal to F L square by EI, integration of dx 0 to L will be L. So this will be FL cube. Calculation में इतनी गलती होती है, मैं क्या बताऊं आपको. X square integration Pn will be common outside. Okay, that is F upon EI. X square integration will be L cube by 3. So FL cube if I take common, so अभी भी गलती होगी, मेरे को पता है मेरी. 1 by 3 plus 1. FL cube if I take common, so 1 by 3 plus 1. So 1 by 3 plus 1 is 4 by 3. So this will be coming, सही हो गया by chance. This one. Have you got it? Give me yes or no. Have you got it? Please give me yes or no. Everybody enjoying it? Cheating पकड़ी गई. हाँ. Now next question. The deflection of the beam at x is equal to L by 2. So guys, deflection chapter, if I tell you the difference of civil mechanical level of SOM, deflection and SFD chapters are usually, see, this will be very easy for civil, na? So deflection and assembly chapter are usually difficult for civil. Of course, they have to work for the deflections a lot more in the building and in their civil related works. But torque chapter, torsion chapters, okay, these and the stress strain curve, this is little bit one step further for the mechanical. The tough questions can be asked because they have to do a lot of work in the shafts. Stress strain curve will be used in production. Theory of failure, they are knowing 3 steps further than us because machine design is totally based on theory of failures. Our theory of failure is only limited to engineering services. Okay. The deflection of the beam at x is equal to L by 2. So let this be A, let this be C. C it is asked. So actually it is asking deflection at C. Actually, it is asking deflection at C. Okay, delta C. Now, this is like this. Okay. And deflection of B with deflection of C, sorry. Deflection of C with respect to tangent at B is equal to delta C. Correct? Because tangent at B point is like this. So with deflection, this is with respect to tangent. But it is equal to actual delta C. Delta C actually also this much. Delta C is actually also this much. Okay. Good, Arun. Good. Good. Yes, aspirant and Ambati is also come. Now, here, deflection of C with respect to tangent at B is equal to delta C. It is actually area of M by EI diagram. So this is M by EI diagram. So area of M by EI diagram between B and C about C. So what is the area? M by EI into L by 2. Movement is L by 4 about C. Movement area into distance. This is area. Movement of area. Na? This is area, this is distance. So this is ML square by ATI. This is ML square by ATI. Okay. Again easy. Again easy. So deflection question civil might be finding easy here. Okay. Now consider a linear rectangular thin sheet of metal subjected to uniform uniaxial stress 100 megapascal. So guys, uniaxial means only in one direction. So this will be sigma 1 major. Shear stress is 0, nothing shear stress here. Uniaxial loading only, one direction, one loading, no shear. So what is the sigma 2 0? Sigma 2 0. Simple. Now plane strain condition, that means sigma 3 you don't have to consider. Young's modulus is given, Poisson ratio is given, the principal strain is asked. So everybody can tell this. Sigma 1 by E minus mu sigma 2 by E given mu given sigma 2 is 0 because it is unidirectional loading. Epsilon 2 is equal to sigma 2 by E minus mu sigma 1 by E. Everything is given. So it will be the D option. It will be the D option. Getting or not? Getting or not? Okay, now Dheeraj sir will be coming with sir's question and then I'll be coming again. Okay. So these questions we have done. अभी इसकी अब की बार second वाले shift में थोड़ा speed पे ले गया मैं लग रहा है मेरे को. Okay. So now धीरज सर तो बहुत गोरे लग रहे हैं क्योंकि लाइट सर की ज्यादा है, ऐसा बात नहीं है. ओके सर, आवाज सर ऑडियो.
Sir, you are saying gore. I thought you are saying bude.
नहीं गोरा है सर. You are much fitter. So whenever we have match between civil mechanical versus electrical electronics, na, so Dheeraj sir and me open the batting, and sir, most time we won also.
But we both open the batting.
But we both, हाँ वही तो कह रहा हूँ सर, we open the batting. And धीरज सर जो बॉल कराते हैं वो जूते उतार के कराते हैं. We book the ground usually in 1 or 2 times in a week. From couple of weeks we have not done this, but we'll be doing. Okay. तो धीरज सर आपका क्वेश्चन है कुछ पॉइंट, कुछ मोर सर्कल कुछ है.
हाँ सर, बट you have not said that majorly we won.
मैंने यहीं तक रटा था बस, अब मैं और रटता हूँ. But sir, we have same PPT but color different. My color is looking some purple and Whatever, your color is
That
looking blue.
that is some OBS settings are different, I feel.
Okay, okay, okay. ठीक है sir, आप
Fine. So guys, now we are having the question from transformation or principal stresses. The state of stress at a point in a component is represented by Mohr circle of radius 100 MPa, centered 200 MPa. So you will take the axis. Let us say this is the center 200 MPa, and then you are having a circle with 100 MPa radius. So we got this. This is the Mohr circle, and they are saying the normal stress axis, okay, on a plane passing through the same point, the normal stress is 260. So they are saying 260 normal stress. Obviously 260 would be somewhere here, because here it is 300. Okay, so we are talking about this point. So in this point, this distance is going to be 260. This was a new type of question asked for the first time in GATE 2019 for 1 mark in GATE. And the magnitude of shear stress on the same plane. So you know that this they are asking. So for that, better if we make the radius. You already know that radius is 100. This is 100. And if this is 200, this is 60. I feel now everybody can apply the Pythagoras to find out this tau value. You can write 100 ka square is 60 ka square plus tau ka square. Very easy question. Very, very easy question. Shri Ram, Meena, good afternoon, dear. How are you? So Anubhav, Arun, Shri Ram, aspirant, solve it. So aspirant, where were you in between? In between, you went, I feel. Okay. Anubhav is saying 80, Arun is saying 80. And I have already calculated the answer for you. Answer is 80. Very good. Wonderful, guys. बहुत ही बढ़िया. Moving to the next question, guys. This time, the question is the state, sorry, the stress state at a point in a material under plane stress condition is equibiaxial tension. It means you will make the point state of stress in 2 dimension and they are equal biaxial. Means this is sigma, this is sigma. And which of the following statement is true? I feel this is very, very easy. Okay, very, very, very easy. Okay. So Mohr circle representation of the state of stress is given by. What easier than this can come? Everyone. Yes, Surya, where are you? Surya, Sriram, Swapnil, Arun, Anubhav, aspirant, Vijaya. Try to solve this. This is the case. Magnitude of 10 MPa. This is 10. So they are saying if 1 unit on the plane is 1 MPa, the Mohr circle representation, the state of stress is given by. Yes, you know that when you will talk about Mohr circle, this time Mohr circle is going to be a point because X phase state of stress is sigma comma 0. Y phase state of stress is sigma comma 0. They are same points. So when you will join them, you will get this as Mohr circle, a point at a distance of 10. Shear stress will be 0. All planes are principal planes. So the answer is going to be B. B is going to be the right answer. Okay, wonderful, guys. Anubhav A is saying that a point on the axis at a distance of 10 units from origin. Okay, actually they have written the same. Okay, so that's why A and B are the same statement here. This is by misprint. Okay, so here I feel this will be 1 unit. Then you will say A is wrong. This was the misprinting. A was having 1 unit, B was having 10 units. That is the difference. And C is saying radius equal to principal stress, not possible. And radius 10 units, not possible. Okay, that is how the thing will happen. Got it? Yes, yes, yes. Yes, Arun. So this is the problem, as sometimes typists also make the mistake. This was a dangerous question. If you see, consider 2 concentric circular cylinder of different material M and N. You can see this is M, this is N. They both are having center at C or O, let us say. Then they are saying they are in contact with each other at R is equals to B. So at this radius means this is the contact point of both the cylinders. This is the contact point of both the cylinders. Then they are saying that the interface at R is equals to B is frictionless. Means at this surface, there is no friction. No friction means no relative motion. Then they are saying the composite cylinder system is subjected to internal pressure P. U R, U theta, and sigma R, sigma theta denote the radial and tangential displacement and stress component in material M. Similarly for N, the boundary condition that need to be satisfied at the frictionless interface. This is a difficult or different type of question, I will say. And first time it was asked like that, but it is, if you go for the solution, not very difficult. Looking the statement seems to be difficult. First of all, this is frictionless, no relative motion. So you must say that the radial velocity when we are talking about, the radial velocity of M and radial velocity of N will be equal. But if you are talking about the circumferential velocity, when you are talking about a thin cylinder surface or any cylinder surface, you know that this is the radial direction and this is the circumferential direction. So whenever we are talking about the circumferential velocity is given as R into omega. So when we are talking about this M and N, when you will be talking about for M cylinder, for N cylinder, radius will be different. So velocities will be different. So that's why I said circumferential velocities will not be equal. So when you are going to say that circumferential velocities are not equal, but radial velocities are equal. So for this case, if you see, radial velocities are given equal here, and here circumferential are given equal, B is wrong. Here, if you see radial, circumferential are given equal, so A is wrong. Okay. And when we are talking about this, either C or D can be the answer. Then, my dear, you can also see that when this is the interface, and you know pressure acting is going to be not change with this M and N, because this is the interface. So that is why the stress is when you will be finding out for M and N. Stress is when you will be finding out for M and N. In which direction? In radial direction. They will be equal. But in circumferential, as velocity is also changing, stress will also change. So the answer for this is going to be C. This is slightly difficult kind of question and different, very different. Never ask this type of question. And I feel this is by chance come. And sometimes these kind of things happen in every paper. 1 to 2 such questions. Moving to the next question, it is in our range. Wonderful question. Consider a prismatic straight beam of length L, pi m, pinned at the two ends as shown in the figure. The beam has a square cross section of P is equals to 6 mm. Young's modulus, coefficient of thermal expansion, the minimum temperature rise required to cause Euler's buckling of the beam is. So I feel here two things are there. First of all, temperature is going to rise. When temperature will be rising, this will try to expand. At that time, reaction will come, and as reaction is coming out to be compressive in nature, it will be a case of coulombs. Ha, Arun, that is of thick cylinder. Okay, that is of thick cylinder. Yes, thick only. But I was showing you the direction because in thin, radial stresses are assumed to be 0. Okay, that is sure. It is thick. So here, what we are going to do, we are going to say the force due to thermal. I feel you everybody know that A, E, alpha, T. This is the force due to thermal. And whenever we are talking about this force, buckling load is pi square EI upon LE square. So, you know, this is going to be compressive. This is going to be tensile because temperature is increases. Okay, and what they saying, the minimum temperature rise required to cause Euler's buckling. So you can say if body is in equilibrium, both will be equal. So you just need to equate them, and equating them, you can get the value of delta T. It is a very good question. First time they have include thermal stresses with the column. Otherwise, thermal stresses were include with the beams only, bars only, shafts only. They have included with this columns also. And we have seen one question today with thin cylinder also. Okay, so this is how the things can be done. So now I am waiting for everyone to answer. Anubhav, Arun, Swapnil, Aspirant, Surya. Try to solve this. When you will equate, you will get the answer. You are given the value of E, given the value of alpha. Try to solve it. Try to solve it, guys. This is from 2019. Okay. Everybody. So length is given to you as pi meter. Length is given to you as pi meter. So it will be pi ka square, pi ka square, pi ka square will cancel out. Okay. 694 Kelvin Anubhav is saying. So I am saying A, E, alpha, delta T equals to pi square and Le square will get cancelled out because it is both hand hinge. So E is 20 GPa, 20 into 10 to the power 3. I minimum, it is a square section of side 6 mm. Side P is equals to 6 mm. So 4I is 6 की power 4 by 12. And you know that area is A square. Young's modulus, actually Young's modulus will also get cancelled out. No need to put the value. This is 6 ka square. Alpha is also given 3 into 10 to the power minus 6. So you will get delta T as equals to. Everyone, I don't feel that answer is correct, Anubhav. Please try it again. It is very easy question. This is 6 ki power 4, this is 6 ki power 2. So it will be 36 now. So when you will cancel out this 12, 3 will get cancelled out. I feel the answer will be coming out to be 1 Kelvin. 1 Kelvin is going to be the right answer. Okay. Okay. When we are talking about the values, this is going to have in mm square. Na? So as everything is given like it is in meter. So you would be having 6 to the power 4. This will be having into 10 to the power minus 6. Why? Because this is 6 to the power square. This is 6 to the power 4. So either you can put 6 to the power minus 12, 6 to the power minus 6. They will also get cancelled out. So this will be cancelling by this. So answer is 1 Kelvin. Arun, you got it your mistake? Arun, got it your mistake? Yes, definitely. Because everything is in meter. You won't answer in Kelvin. This can also, this is only Kelvin inverse. So every other thing is, we have converted in meters. So it should be like that. Very good, Surya. Moving further, guys. Now this is the next question. This is from trusses, engineering mechanics. Okay. So we will see this question in engineering mechanics, because without that concept, we cannot solve it. Then next question. Next question. Here he is saying uniaxial compression test data for a solid metal bar of length 1 meter. So length is given to us as 1 meter. Then he is saying that the bar material has a linear elastic response from O to P. From O to P, it is going to be linear. The point P represents the yield point of the material. This point is showing the yield point. So you can say SYT yield strength is 100 MPa. Okay, that is mentioned. Now he's saying what? The point P represent the yield point. The rod is pinned at both the ends. Okay, rod is pinned at both the ends means it is a case of both end hinge column problem. Okay, yes, column problem. Then he is saying that it does not buckle under axial loading before reaching the yield point. For that, you need to tell the minimum diameter, my dear. Yes, very good, guys. So you are going to apply the force, and he is saying that buckling should not happen. For that, what should be the diameter? So you just need to put what? You know that buckling load is pi square EI upon L square, LE square. If you are going to do PE by area and equate it with the SYT, I feel you will get the answer of diameter. So just do this. This is very easy question. From the figure, it looks like very difficult. From the statement, you may feel what it is. But if you see, it is very simple. You just need to equate this. Load but area is equal to stress. And you will be getting the diameter. This is the question. So guys, just solve it. Then this is the, you can say now we have done a lot of questions. Very few questions are left for our side. Yes, solve it. I have already done it for you. Let us see how many of you give the right answer. Okay. So PE by A is SYT. PE ka formula is there in front of you. And we need the value of diameter. Very easy question. Everybody. Then we have some questions from theories of failures. We have some questions from tensile testing. Okay. Many questions are there, and also from principal stresses. Or you can say transformation of stresses. Anybody? What we are doing is PE by area is SYT. You can also write pi square EI upon LE square is equals to SYT into area. Okay. And you need to find out diameter. That is what you need to find out. Yes. Anybody? You can also do one thing if you want. You can also write E as sigma by epsilon. But the things will not change by that. So when we are solving this, according to my data, the answer is coming out to be D minimum as 56.94 mm. Everyone. Are we getting that? Swapnil, Arun, Anubhav? Please tell me that. $56.94. Yes, that is the correct answer. If you want, I am telling you, I am helping you how to find out Young's modulus. Young's modulus is the slope. You can find out. This is the hint I feel you are looking for. Anubhav, answer will be coming 56.94. I feel you have made small mistake because you are getting half of that. So this is the stress, this is the strain. This will give you Young's modulus as 100 divided by 0.002. Okay. Stress by strain is Young's modulus. Everyone got it or not? This is actually using the concept of column as well as tension test. Yes, very good, Anubhav. Yes, Arun, Surya, everybody got it. Shall we move on now? So this is simple calculation. I feel you can do this. Okay, next question. Yes, Abhinav sir would be taking next question. Please tell me, is it clear for you? Tell me. Yes, sir. Okay, till sir joins us, let us solve 1-2 more questions. Let us see this question. Okay, let us see how many of you give right answer for this. Okay, sir is coming.
मैं म्यूट पे था इसलिए.
Okay, sir. Sir, then you take your question, then I'll come back.
Okay, sir. Okay. So I'm seeing Anubhav, Arun, Swapnil, Surya, all the students' dedication is top level here. Top level dedication. Arun, Sriram, Swapnil, Juhi, Anubhav, Surya. Excellent. And guys, let me again tell you, the civil students, that today only survey will also be there. Survey marathon. Today survey marathon will be at 5 p.m. Okay, that will be not that much big because the number of questions of survey are quite less. So are you coming there? Swapnil, Anubhav, Arun, Komalabad. Okay. So now what is the question? Kahan gaya? Oh. Okay. So this is the question, that when one end is fixed and other is free. Okay. When one end is fixed and other is free. When this is the blue case, one end is fixed, other is free, then we can apply a 100 Newton load. So what is L effective here? L effective here is 2L. And load is directly proportional to 1 by L effective square when all other terms are constant. Now what is happening? The free end is replaced by a pinned end. So this is fixed, but here it is pinned now. Here it is pinned now. So what will the load? Here L effective is L by root 2. So this 100 by this will be proportional to L effective. So this 100 of blue color, and now new case is this PCR. I am writing this as PCR is equal to, it is proportional to 1 by L effective square, is equal to proportional to L effective square. So this is L by root 2. 100 is equal to 1 by L effective. So L effective here is 1 by 2L. So what divided by this and this? Okay. So this will be, I have to write L by root 2 whole square. So that means 1 by 2 divided by this blue one. So blue one is how much? 4. So from here, the PCR 1 by 8 is equal to 800 Newton. Is equal to 800 Newton. Answer is equal to 800. Have you got it? Yes, absolutely, Dheeraj sir. Excellent dedication shown by the students. And today, the civil students survey marathon will be there. And for mechanical, guys, we are having a launch for the new upcoming series of ISRO. Now, Dheeraj sir, ये वाला क्वेश्चन एक बार आप देख लेना मैं सही कर रहा हूँ कि नहीं. What is the factor of safety on the basis of maximum shear theory? What is maximum shear stress theory? That tau max should be less than equal to tau max in uniaxial loading. Okay, tau max should be less than equal to tau max in uniaxial loading, and uniaxial loading is 1 is 0, only one direction load is there. So what is tau max? If this is sigma y, so tau max is sigma y by 2. So this should be less than sigma y by 2. Okay, so tau max should be less than equal to, if I'm using for design, this is analytical, and this is the case. This is the case as by Tresca and JJ Guest, if I remember. Maximum shear stress theory, Tresca and JJ Guest, whoever is given, I'm taking the wrong name. Dheeraj sir, name उस scientist का Tresca and JJ Guest ही था क्या?
Yes, sir. Yes. Guessed it.
Oh,
Correct.
ओके थैंक यू सर। तो अब इसका टाउ मैक्स इज लेस देन सिग्मा वाई बाय टू, सो यहाँ से टाउ मैक्स निकालते हैं। टाउ मैक्स वी विल बी कैलकुलेटिंग हियर, सो 100 स्क्वायर, अरे बाप रे बाप, तो खतरनाक कैलकुलेशन बनेगा। सिग्मा एक्स माइनस सिग्मा 120 स्क्वायर, अच्छा 120 का नीचे डिनोमिनेटर भी होगा, सिग्मा 1 माइनस सिग्मा एक्स माइनस सिग्मा वाई बाय 2, 220 माइनस 100, 120 बाय 2 इज 60 स्क्वायर प्लस 80 स्क्वायर, सो दिस विल बी 6436। तो ठीक है, आसान बन गया। 6004 दे कितना बचेगा, 10,000 रुपए। 10,000 रुपए का स्क्वायर रूट करेंगे तो बनेगा 100, सो टाउ मैक्स शुड बी लेस देन 100। सो यहां से जो कंडीशन बनेगी, द टाउ मैक्स वी आर गेटिंग इज 100 should be less than sigma y by 2. Sigma y is कहाँ गया, 468, so 468 by 2 is 22234, 234 by factor of safety. So factor of safety पूछा है क्या, factor of safety is equal to 2 point, सर ये सही है क्या, धीरज सर ये सही है क्या?
Yes, sir. Sir, let me see.
इसका आपने सोल्यूशन नहीं भेजा था, साहब मैंने मेरे को दिखा।
Sir, actually,
मैंने
I thought it is theory of failure. So,
हाँ, theory of failure for civil gate it is not coming ना।
1.8 is correct. 1.8 it will come, I feel.
ओके तो कैलकुलेशन मिस्टेक हुआ कि कुछ बवाल मचा दिया मैंने। सबसे पहले टाउ मैक्स निकालेंगे ना, 120 60 स्क्वायर प्लस 80 स्क्वायर तो 100 आ गया, फिर दैट टाउ मैक्स शुड बी लेस देन टाउ मैक्स आया 100, सो 100 शुड बी लेस देन सिग्मा वाई बाय 2, सिग्मा वाई इज 460। तो स्टूडेंट्स यू कैन आल्सो टेल मी 1.17 कैसे भाई?
Sir, actually, we will be finding out first of all principal stresses, na?
ओके फिर देन सिग्मा 1 माइनस सिग्मा 2 बाय 2, सिग्मा 2 माइनस सिग्मा 3 बाय 2, सिग्मा 3 माइनस सिग्मा 1 बाय 2 का मैक्सिमम।
Yes, yes, sir. So it is a plane stress condition. So for plane stress condition, whenever we are talking about, you will get sigma 1 and sigma 2 both are positive. So when we have calculated sigma 1 and sigma 2, you will get 260 and 60. So when principal stresses are coming of same nature, then at that time Tresca follows the same relation as given by Rankine. So you will directly say here sigma 1 should be less than equals to SYT by N. So that will give you N is equals to 1.8. Actually, Tresca agrees with Rankine theory when principal stresses are of same nature. When principal stresses are of opposite nature, then that is valid what sir was doing, sigma 1 minus sigma 2.
ओके हाँ, तो हमारे सिविल में तो वैसे ही बता जैसे मैं
किया वैसे ही है, तो that's why मैंने आपको ये क्वेश्चन दिया नहीं था, I thought कि I will be taking this. This is actually core mechanical related to machine design part. Okay, so if civil people are not able to do this, that is correct. Because if you will be able to do this, then mechanical student will feel कि इतना पढ़ने का क्या फायदा. So don't worry, for this question you can feel free, no issues. Okay, that is very much in depth of theory of failure. Okay, sir. Mechanical also this question came for the first time like that. So this was difficult.
Okay, thank you sir. आपने अच्छा इसके बाद मेरा है क्या? अच्छा सर का ये
next is mine.
आपने बचा लिया मेरे को इज्जत से, इज्जत से। ओके सर, सर आपका है नेक्स्ट तो आप
yes sir.
Okay.
So guys, moving to next question, one more theory of failure question. So the von Mises stress at a point in a body subjected to forces is proportional to square root of what? Total strain energy per unit volume, dilational strain energy, distortion strain energy, or normal strain energy. This is a very easy question from von Mises. Sir, ESC civil में भी आता है. Okay. हाँ, ESC civil में आता है, but as I said, this type of questions are core design related. Okay, this is very easy. So dear, I would like to tell you, just remember with this table, maximum principal stress theory takes criteria to be normal stress. Maximum shear stress theory takes criteria to be shear stress. Maximum strain energy theory takes criteria to be strain energy per unit volume. This is maximum distortion energy theory. This is the name of von Mises theory. So this takes distortion energy per unit volume. What is distortion energy? Actually, total strain energy is having two strain energies. One is volumetric, other is distortion. Volumetric responsible for change of volume, and distortion is responsible for change of size. Sorry, change of shape. So for MDET, which was given by von Mises, you will say that ki distortion energy per unit volume is the criteria. So answer will be C for this. Answer will be C for this. Okay, very good CAD back. तो इस क्वेश्चन को देख के मैकेनिकल वालों को जोश आ गया थ्योरी ऑफ फेलियर में. Okay, so no issues, guys. Those who don't know, I told you with this. Okay, the last theory is maximum principal strain theory. It takes criteria to be maximum value of strain. So this was given by Rankine, this was given by Tresca, given by Hayes, given by von Mises, given by Saint-Laurent. Don't worry, this is a very small chart of one page where all the theories of failures can be remembered. Okay, so I will try to add that slide here so that civil peoples can also get an idea. Otherwise, no requirement for civil. For mechanical, it is core in depth. Moving further, once again, UTM. This is also from the testing of materials. So this topic is also not mentioned in the civil engineering syllabus. This is from testing of materials, but you can do it easily because it is very simple question. Koi baat nahi, Arun, if you remember, we have taken a marathon session also, me and Abhinav sir. Once again, we will be coming up with such sessions. There I will teach in great detail. If you want theory of failure, I will teach in great detail. So there you can get that. So in a UTM experiment, a sample of length 100 mm was loaded in tension until failure. The failure load was 40 kilonewton. The displacement measured using the crosshead motion at failure was 15 mm. The compliance of UTM is constant and is given by, I feel you know this is inverse of stiffness. The strain at failure in the sample is. This question everybody can answer. Okay. It looks like this is from tensile testing, but everybody can do that. Just solve it. I am looking for your answers. Compliance is given to us. Yes. So delta L is delta LR minus this C into P. And you need to find out this, and after getting this, strain is delta L by L. You need to give the answer in percentage. C is compliance. C is compliance. This is the formula. Question from tension test. So they have already mentioned you this 15 mm, 40 kilonewton, length is 100 mm. So compliance you already know, delta LR is 15 mm minus compliance is 5 into 10 to the power minus 8. This can also be 10 to the power minus 3 because it is in mm. Into P load is 40 kilonewton, 10 to the power 3. Whatever you get here divided by length, that is going to be your answer, and get the answer in the terms of percentage. Solve it, everyone. And we are about to complete. Very few questions are left now. This is from 2019 for 2 marks. Now only we are left with the questions of GATE 2022. All others are covered. Everybody. So when you will be finding out this delta L dividing by length, you will get the value of strain. So delta L is coming 0.013 meter. 0.013 meters. So 0.013 meters divided by is 100 mm. Divided by is 100 mm. So 100 into 10 to the power minus 3. Okay. So when you will be finding out this, the strain value will be coming out to be 13% after multiplying it with 100. 13% will be the answer. Okay, 13% will be the answer. Shri Ram Meena, for that, I feel Abhinav sir would be able to answer properly. So sir's questions are also coming because RCC and Yes, very good, Arun. Your answer is correct. But when you will find out in terms of percentage, we need to multiply it with 100. Okay. Yes. So now Abhinav sir would be discussing the question as well as the points, Sriram, you are asking. Because RCC and steel are the part of civil engineering. Okay. So I feel sir is coming. Till then, let us solve one more question. One more question from my side before sir joins us. Assuming the material considered in each statement is homogeneous, isotropic, linear elastic, and the deformation are in the elastic range, which one or more of the following statement is true? A body subjected to hydrostatic pressure has no shear stress. If a long solid steel rod is subjected to tensile load, then its volume increases. Maximum shear stress theory is suitable for failure analysis of brittle material. If a portion of a beam has zero shear force, then the corresponding portion of the elastic curve of the beam is always straight. Yes. That is correct. Arun, 13% will come. Yes. When you will go for percentage, multiply by 100 will give you 13%. What will be the answer for this? If you see this, the very first statement, a body subjected to hydrostatic pressure. Hydrostatic pressure means this is the state of stress, compressive. You know, for this case, we are having Mohr circle as a point. When Mohr circle is point, the radius of Mohr circle is 0. When radius of Mohr circle is 0, radius of Mohr circle is 0, it means shear stress is 0. So A option is correct. Yes, it is. And the second option says if a long solid body, if you are having this, you are applying the tensile forces. Then, my dear, you know, length is going to increase, area is going to decrease. Generally, the longitudinal strain is going to be more than the lateral strain, because it is mu times of longitudinal. So because of that, when you will find out the total volumetric strain, it is going to be more or positive. It means yes, volume increase. This is MSQ. A and B are going to be correct. Maximum shear stress theory is applicable for ductile material. That is why this option is wrong. If a portion of beam has zero shear force, then the corresponding portion of the elastic curve of the beam is always straight. So that is not correct, because if bending moment will be present as constant, then we will be having the circular arc. So that is why the option is also not correct. I feel everybody is aware of this. Very good, Arun. Very good. Is it clear for everyone? Everybody understood it is MSQ. Please tell me that. Okay, if you have any doubt, I am showing you this. Like if we are having a beam like this, we are going to have a force like, we are having a beam like this, we are having a bending moment like this, and shear force like this. Then you know A, B, C, D. For this part of beam, shear force 0, bending moment 0. So here you are going to have straight line deflection curve. For this case, BC, you have bending moment constant, shear force 0. You will be having circular arc. And for this case, shear force variable, bending moment variable, shear force constant, bending moment variable. So here you will be having parabolic deflection curve. Is it clear for everyone? Okay, I feel Arun is trying to answer. Sri Rambina. Okay, fine, guys. So this is the case, and this is coming by this. M upon EI is equals to 1 upon R. So when bending moment will be 0, R will be infinity, straight line. When bending moment will be constant, R will be constant. When bending moment will be variable, R will be variable. Okay, this is how the things are coming. Next question, guys. Which one of the following is the definition of the ultimate tensile strength? Very easy question. stress value where the stress strain curve transition from elastic to plastic behavior. I'm showing you that diagram as well. The maximum load attained divided by original area of cross section. The maximum load divided by corresponding instantaneous area. Stress where specimen fractures. So I'm telling you, here we are going to have the starting of plastic deformation. That is our yield strength. This is our fracture point. And this is the ultimate value of stress. And this diagram is engineering stress versus engineering strain diagram, where stress is defined as force but a original area. Which option will be correct? Which option will be correct? Arun. Okay. CAD mechanical have said D is the right answer. Anubhav is saying C is the right answer. Harshit is saying C is the right answer. So dear, I would like to say whenever they are talking about the ultimate tensile strength, this is defined on engineering stress versus engineering strain diagram. In engineering stress, we have original area of cross section. So one thing is clear, denominator should be original area, not instantaneous area. So that is why this option is wrong. Then my dear, this is the ultimate strength. This is not the fracture point. So D is wrong. Stress value where stress strain curve transition from elastic to plastic is the yield point. So that is also wrong. So only B is the correct. Because here the load is maximum, which is divided by the original area of cross section. Because when you make P delta curve, that also comes like this. So when you divide this value of load by original area, you will get the ultimate value of strength. Is it clear? B is going to be the right answer. Swapnil, stress strain diagram. Is it clear? Any doubt, please ask. Jitin, very good. Everybody got it? Arun, bahut badhiya. Any doubt, please ask. B will be the right answer for this. I already give you the reason. This definition is for yield strength, where plastic deformation starts. This fracture point is totally different. Out of these two, this is correct for ultimate strength. This is correct for true stress. This is correct for true stress. Yes, Anubhav, very good. Swapnil got it or not? Please tell me. Thak gaye kya? Yes. I feel this is now the last question from my side, after which Abhinav sir will be coming for his last questions. Okay. This is from GATE 2022 afternoon session. A linear elastic structure under plane stress condition is subjected to two sets of loading 1 and 2. This is uniaxial loading, you can see, and this is one more loading is acting, but this is inclined by 45 degrees from the x-axis. The resulting state of stress at a point corresponding to these two loading are as shown in the figure below. These two sets of the loading are applied simultaneously. Then the net normal component of stress sigma xx is, means these two loadings are applied on a component, and you need to find out the net sigma. The net sigma means net normal stress. Obviously, it is going to be, let us say this is first, this is 2. So this is going to be the effect of sigma for 1 plus effect of sigma for 2. The effect of sigma in x direction, it is simply sigma. You need to find out this component, and then you will be able to answer. Angle given is 45 degrees. Try to solve this. Yes. No issues there, but that hard work of yours will pay you at the end. Okay? Because you will be habitual of sitting 3 hours, which is the major challenge for the GATE students. Because at that time, many students are getting tired in 1.5 hours. After that, they are just completing the paper and completing the 3 hours. Not with that much intensity which is required in paper. So these type of session will also give you a sitting time of 2.5 to 3 hours, which will make you prepare for that. Because your mind shall run for all the 3 hours. That is required. Okay. So let us see. From x-axis, this is making an angle of 45 degree. Okay. So I feel if you want to find out the normal component for this, you can apply the formula sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. Is it clear? Is it clear? So you just know that if you see this, sigma xx for this is sigma, sigma yy for this is 0, tau xy for this is 0. Put these value here. Put theta is equals to 45 degree and you will get the value sigma theta at theta is equals to 45. And you just need to add this component here and get the answer. Okay, so Anubhav is saying the answer to be B. Okay, what about others? So you must be aware that tau xy is 0, this will get cancelled out. If you have any doubt, I am showing you. Because of this, normal stress will be simply sigma. And because of this is given to us. And we want the stress value in this direction, which is at an angle of 45 degree. So you can see if you are going to make the angle, they have shown that with the x-axis, the angle made is 45 degree. So for this, you will apply the formula sigma theta, where theta is theta 45. Sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. You know there is no shear component in this, tau xy will be 0. There is no sigma yy because sigma yy is not there. That is 0. That is 0. So we are left with sigma xx. Sigma xx is sigma by 2 plus sigma by 2 cos 90. I feel everybody is aware cos 90 is 0. It is sigma by 2. So what will be the answer? What will be the answer? Everybody. Everybody. Yes, yes, yes. Anubhav, Swapnil. What will be the answer for this? Go to your mistake, Anubhav. Theta is 45 degree, but 2 theta is 90 degree. Cos 90 is 0. So the answer for this will be 3 sigma by 2. And 3 sigma by 2 is option A. So guys, with this, we have completed this. So now Abhinav sir will be coming for his left questions. Yes, sir.
सर ये वाला क्वेश्चन हो गया?
नहीं सर, this I will be taking in the last. This is the last question, ना?
ये नहीं ठीक है, मैं करता हूँ.
हाँ, okay, sir.
Okay, so guys, now next question, 2022 set 1 question of 1 marks, a beautiful question. Guys, what is asked here? Okay, before that, someone has asked. Sriramina is here. Some doubt was there, na? Ki why the L effect is different, guys. In SOM, we deal with the ideal conditions. Okay, it is pinned. It is fixed. Fixed means theta is equal to 0. We assume everything to be weightless. Okay, so see what is actually L effective? It is the distance between 2 points of contraflexure. Basic pe jao na aur jad pe jao. What is L effective? L effective is the distance. Hi Meena, first of all tell me, are you in the comment box? Otherwise okay, other students can get. Arun he was saying correct. There are various values of L effective in RCC. Because L effective, the basic thing is the distance between the 2 points of contraflexure, and in contraflexure means where bending moment changes sign. So here in strength of material, it is very easy to make the BMD. But in complex structures where it is joined by other members also, so force will be transferring, and maybe the point of contraflexure may be different, because here when we are saying it is fixed and free. So that is only fixed and free in the whole world. We have only one thing, one member. But in RCC and steel, they are jointed by other members also. The force can be transferred, so the bending moment can be different, and the bending moment can be different. So point of control axis can be different, and accordingly the L effective is there. Have you got it, Sriram? And there also the L effective is not written like both side pin, both side fit. It is like constrained in horizontal direction, rotation in Z direction like this. Okay, got it? Okay. Now L-shaped member is there, this one, and force P is acted on this pin. The condition is that it can only move horizontal. Okay, it has a constraint. We are restricting to move only in horizontal. Now, a horizontal force P is applied. Given the length of the beam AB is 4A and this is A, what we have to find out? We have to find out the magnitude and direction of normal force. The magnitude and direction of the normal force on the pin from the slot. Okay. The magnitude and direction of normal force. The magnitude and direction of normal force on the pin from the slot. Pin पे कैसा लगेगा from the slot? इस pin पे ऐसा कुछ pin joined है, ऐसा कुछ perpendicular कोई pin join है, उस पे कैसा force लगेगा? But before that, if I draw the free body diagram of AB, how it will be? Free body diagram of AB will be P is applying a movement here, PA. P will be applying a movement, PA. Correct? Yes. Here the member will be PA. If we see the free body diagram of AB, the P will be applying a movement, PA. Now, guys, 100% a downward force will be coming. 100%. 100%. Why? Because A can move only in horizontal. That means the length is not changing. That means the point B is fixed. If I see the one order analysis, guys, this B point will not be moving. The net deflection of B has to be 0. The net vertical deflection of B has to be 0. Okay, net vertical deflection of B has to be 0, guys, because A vertical deflection cannot be there. It is pinned. Okay, it is pinned, so its vertical deflection cannot be there. And if nothing is mentioned, so this CB member is also called axially rigid. So it means its length is not changing. So that means the net deflection of B is 0. And this P into A is putting it upward. This P into A is putting it upward. And this F will have to put it downward, so that net deflection is 0. So both this green delta and blue delta has to be same. And for this blue delta, the F force has to become like this. The F force has to become. So first of all, please give me, have you understood why this vertical force is coming? Because everybody who is seeing from this outside, he will be saying this for P load, a horizontal P reaction will come. Why vertical? Why vertical? For horizontal P load, a vertical P will be coming. Sorry, for a horizontal P, a horizontal reaction will be coming. Why that vertical load is coming? Have you understood? Because the net deflection of B has to be 0. Why net deflection of B has to be 0? Because this is not moving anywhere. This point, green point, this hinge is, the pin is not moving anywhere. If this is not moving anywhere, and if this length is constant, so B has to be at the same point. Give me yes or no, everybody. Okay. So now the movement of PA, the upward movement of PA is ml square by 2a MPA into 4a square by 2EI, and the downward movement of F is equal to FL cube, F into 4a cube by 3EI. From here, guys, what is the value of F? Please tell. Whatever is the value of F, please tell me on the comment box. Kitna answer aaya? F is coming 3p by 8. Please tell me. F is coming 3p by 8. Okay. So F is coming 3p by 8. And if you see pin, if you see the free body diagram of this part, body diagram of this part, okay, so this F force will be acting upward because internal opposite, and from this end it will be downward. So 3p by 8 downward. Nahi aaya samajh. Guys, if this is downward force here, so in pin also there it is also downward, na? Got the explanation? Got the explanation? Okay, now this. Suppose I am considering this B joint. In B joint, one is the weight downward. Okay. One is this FBC and one is FAB. Okay. And this angle is how much? 30 degree. So vertical component FBC sine 30 is equal to W. So FBC is equal to 2W. FBC is equal to 2W because vertical FBC sine 30 has to support W. Okay. And this FAB is horizontal component of FBC. So 2W into cos 30. What is cos 30? Root 3 by 2. Okay. So FAB is equal to W root 3. And this FAB is actually the compressive force here. Tell me. FAB is equal to W by root 3. Okay, direction फिर से बता देता हूँ इस क्वेश्चन के बाद फिर से बता देता हूँ. First of all, tell me, have you got FAB is W root 3? Okay. Now what is, and this compressive force, column wala concept will be coming. So PCR is equal to N square, N is 1 here, pi square EI upon L effective square. So what is PCR? What is PCR? PCR is W root 3 is equal to pi square EI. What is L effective? Both side pin. L square, that is 2.5. So what is the value of, what we have to find out? What is the value of beta? What is the value of coefficient? That coefficient will be coming. Simplify this. That coefficient will be coming 0.0924. Please check. 0.0924. Okay. Have you got this, everyone? Now let us come back to the Anubhav. Anubhav, see, this F is coming downward. In this beam, it is fine. Okay, if I see this orange part, so F is here downward. Okay, so F here is coming downward. So this downward F, which force is transferring this F downward? This one? This one? Yes or no? This member is attaching there, na? That is only will be providing the F force, nah? Tell me, please. Tell me, please. Give me yes or no, yeah. Nobody is commenting. कुछ इज्जत है कि नहीं है भाई? जल्दी बोलो. Okay, so internal force equal in magnitude, opposite direction. This is downward, so here it is F upward. This is downward, so here it is upward. For balancing this F, this will be like this. So that is transferring the downward force. Okay, the magnitude and direction of the normal force on the pin from the slot. On the pin from the slot is downward. This one is coming downward. Have you understood now? Have you understood now? Okay. Now, yes, this one. This one, guys. Tell me fast. Attempt it and give me explanation. Okay, see. थोड़ा डिटेल में जाना पड़ेगा इसको समझाने के लिए. This was asked in 2022 in forenoon. We have to go in little bit detail. See. This is a section. Cylinder. And this cylinder is filled with pressure P. Okay. Now, after this cylinder, leave this question first of all, understood the concept. Let me cut it here at section XX. Let me see, cut the section XX. After cutting the section XX, it looks something like this. This thickness is T, and like this. This is the section XX. This is the section XX. Now, if I take a very small element here, this one, here hoop stress are coming in this direction. So hoop stress is causing diameter change. That means circumference. Circumference is also diameter, na pi d. So hoop stress, and this stress is coming to change its length, sigma L, length change. And if I consider this one here, the pressure P is acting. Radial pressure, that is decreasing the thickness. Okay, that is decreasing or changing the thickness. So sigma H is responsible for diameter or circumference. This is responsible for change in length, and this is responsible for change in thickness. If nothing is mentioned, radial pressure is almost zero, negligible. Why? Radial stress is negligible as compared to the sigma H and sigma L. The value is very, very less if it is not given. This radial stress. Okay. Now, the obvious reason is sigma H value for cylinders is PD by 2T, and it is PD by 4T. Okay, D is 2R, so it can be written as PR by T. D is 2R, so it is written as PR by 2T. Now, this is thin cylinder, it should be written somewhere, thin. So thin means T is, guys, I have not started the question now. Thin means T is very, very less. Thin means T is very, very less. So if T is very, very less, that means sigma H is very, very big and sigma L is very, very big. So this statement signifies sigma is very greater than B, and similarly sigma L is also very greater than P, because thickness is very small. The thickness by radius or thickness by diameter ratio is more than 15 and 20. T by D. Oh, sorry, D by T is more than 15 and 20. T by D is 1 by 15 to 1 by 20. That means sigma H is very, very big and sigma L is very, very big as compared to P. Now, guys, here let us come to this question now. Normal perimeter means diameter. Diameter. So what is epsilon D or epsilon perimeter? It is sigma H by E minus mu sigma L by E. Okay, radial pressure is 0 considering. So sigma H is equal to PR by T by E, and that is PR by 2TE. So taking PR T by E common, PR and E is also common. PR by E common. Now sigma H is 1 by T. Okay, T also common. So here it is 1 minus there. Sigma L is this. So 1 minus mu by 2. And this value is 0.1%. Check this. Check this. Everyone. This value, that is PR by, if I do it 2TE, if I do it 2T, epsilon D is equal to PR by 2T dividing by 2 multiplying by 2. 2 minus mu is equal to 0.1 by 100. That is given in the question. That is given in the question. Okay. Now radial strain. Okay, radial strain if I want. Here, this radial stress. Now what will be that? So epsilon radial is equal to minus P by E, and here minus mu sigma H by E minus mu sigma L by E. Instead of sigma L, this can be termed as 0. So radial strain here, let me check. Everybody, just tell me fast, come on. So this radial stress, this will be 0. Of course, sigma PR will be 0 minus mu sigma H and sigma L. So this is PR by T, and that is PR by 2. PR by T, 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. 1 plus 1 by 2 is 3 by 2. So 1 by E minus 3 by 2. Okay, minus means decreasing. 3 by 2. And here it is PR by T. PR by T, please, mu is also coming. So mu mu 3 mu upon 2e PR by T. Check. 3 mu PR upon 2 TE. 3R. R will also come na. R we have forgot. 3R mu 3R mu upon 2 TE. Check. Yes. So that is radial is changing what I told you concept. That is delta T by T. That is radial is I told na. This is changing the thickness. This is thickness here. Come on. Everything I have figured. So from here, kahan gaya? From this value is 0.1 by 100. So from here, find the value of PR by 2T. Mu is given na. Mu is given na 1 by 3. So from this statement, find the value of PR by 2T in terms of, because these values are known, put it here. You will get delta T by T. You will get delta T by T. Okay, from here, delta T by T, you will be getting as, please check 6 into 10 to the power minus 4. Delta T by T is minus 0.06%. Okay, 0.06%. And this value, 100 T bar, that is new, it is coming to be, please check, minus 0.06%. Give me yes or no. Everybody on the comment box. Any doubt, please let me know. Little difficult पड़ गया मुश्किल में. कहाँ गए comment? Okay. Now कितने ये हो गया. Last question is from my side is this one. So guys, a rigid beam AD of length 3A is equal to 6 meter. This is 6 meter. So A, all are AR2 is frictionless pin joint at A. This is frictionless pin joint at A, supported by 2 springs shown in the figure. So this spring is again, so that means carrying the same tension. Similarly, string BC passes over 2 same pulleys. Okay, negligible radius. All the strings are made of the same material and have equal cross-sectional area. F is equal to 9 is applied at C. So here it is in 9. Okay. Now, the self-weight of the beam is negligible. Assume all deflections and tension developed in the string at C is. So here the tension is asked. So first of all, let me take a bigger new slide. Let me now go to here. Now copy and now let me do paste here like this. Let me make it little bigger like this. Okay. So first of all these values are 2 meter, na? This is 2 meter. This is 2 meter. This is 2 meter. And at C, how much load is applied? 9 kilonewton. Here, this load, this 9 kilonewton. Since they are passing from the same pulley, so tension will be same. Let the tension here be T, and this tension is also T. This may be different because they are independent, maybe T dash. Okay. Now, as this is rigid, so I told you many times, whenever this rigid word is there, so that means it cannot bend like this. This is rigid, mazak nahi ho raha hai. This is rigid. So rigid will be deflected somewhere like this, straight. So if here it is delta 1 and here it is delta 3, then similar triangle, delta 3 by delta 1 is 3A by A. So delta 3 is equal to 3 delta 1. First of all, before moving forward, any doubt till here? If I go forward, before that, tell me any doubt? Any doubt till now? No doubt. So what is delta 3? Why I have not taken delta 3, 1 and 2? Because 1 and 2 will be same, now tensions will not be coming different. I want different equations of T and T dash. I want different equations of T and T dash. So deflection of 3, this one is T1 into L by AE, 3 delta 1 is equal to T into L by A. Now it has already said that L, A, E are all same. It is said that L, A, E are all same. Spring has same thing. So T1 is equal to 3T. T1 is equal to 3T. Give me yes or no. Give me yes or no. From here, if this is hinge, so summation of moment about A is equal to 0. So if any reaction is that is passing from here, see this, consider this part now. So here T into A anti-clockwise, that T into 2A anti-clockwise, this 9 into 2A clockwise, and that T dash anti-clockwise. That actually it is not T1, it is T dash. T dash, that is also anti-clockwise. T dash into 3A is equal to 0. Okay, हमें find out क्या करना है? Small tension developed in the string at C, that means T. So instead of T dash, it's better that if you write T, because we don't want T dash, we want 3T. So A all are cancelled. Okay, so minus T and minus 2T, minus 3T, minus 3T and minus 9T, minus 15T is equal to 18. So T is equal to 18 by 15. So it is 6 by 3. Please check. Please check. It will be 6 and 6 by 5. No. कुछ तो mistake हुआ है, गड़बड़. This will be T into 2A. T into A. Okay, anti-clockwise. Now here T into 2A. Okay. Now 9 into 2A clockwise. Okay. And 3T into 3A. So T and 2T is minus 3. Minus 3 and minus 9 will be minus 12. So this will be 12. So 18 by 12 is equal to 1.5. So value will be coming as 1. Give me yes or no for this, yaar. Give me yes or no. Everybody on the comment box. And guys, I am again telling you that we will be coming. I will be coming 5 p.m. I will be coming 5 p.m. with survey marathon. That will be small. It will not take much of the time. Okay. So 5 p.m. I will be coming with survey marathon, and in night the mechanical team will be coming with the super duper surprise for you. Okay. So I guess now my all questions are done. 2023 na, for 2023 the link will be provided in the comment and description box. Okay. Yes, Dheeraj sir, अभी शायद आपके कुछ क्वेश्चन बचे. Sir, वो आवाज.
Sir, last question, only this one.
Okay, sir. Okay.
So guys, this is the last question of 2022. And for 2023, already the session is available in which the complete paper is sold. So this is the last question for this session as well. And this is from torsion again. So as sir already told that for torsion, mechanical questions are very good. A shaft of length L is made of two materials, one in the inner core and other in the outer rim. You can see this. It means everybody got an idea from this that it is the case of shaft in parallel. Everybody got the idea that it is a case of shaft in parallel. Here this material is different and the other material is different. So this is parallel connection. Then he is saying that the two are perfectly joined together, no slip at the interface along the entire length of the shaft. The diameter of the inner core di and the external diameter of the outer is d naught as shown in the figure. The modulus of rigidity of the core and the rim material is gi g naught, and d naught is 2 times of di, gi is 3 times of g naught. When the shaft is twisted by application of a torque along the shaft axis, the maximum shear stress developed in the outer rim and the inner core turned out to be tau O by tau I. All the deformations are in the elastic range. What is the ratio of tau I by tau naught? So guys, this is a very good question. Okay. So I feel everybody will be able to solve this. I am giving you the hint for that. First of all, you tell me when the shafts are in parallel, then angle of twist will be same or not for both. Tell me that. The angle of twist will be same or not for both. Yes, Sachin, good afternoon. You are very late. Eh? You are coming at the last question. Sachin. Okay, tell me, in the parallel, angle of twist remains same or not? Angle of twist remains same or not? Yes, the same you will be starting with. So you will write theta of inner one is equals to theta of outer one. So when you will go for this, it is Ti, Li, Gi, Ji is equals to To, Lo, Go, Jo. From that, you need to find out the ratio of Ti by T naught. That ratio you will get because you are already given two things. What are those two things? The Gi is 3 types of Go. D naught is 2 types of Di. This is given to you. And you know J is pi by 32. Di ki power 4. And J will be pi by 32. D naught to the power 4 minus Di to the power 4. These are the values of J for inner and outer. So you will be getting the ratio of Ti by T naught when you will solve it. Then you know that you need to find out tau I by tau O. So I feel everybody is aware that tau by R is T by J. So you can write tau as TR by J. So you just need to do that. Ti Ri upon Ji. T naught R naught by J naught. So you already know the ratio of Ti and T naught. You already know Ji, J naught because Di and D naught are known to us. So by solving this, you will be getting the ratio of Ti by tau naught. That is the question asked. It is a very good question, I feel so. Okay. Yes. So guys, if you see this, I am giving you a hint also. Like when you will be solving this, the Ti by T naught ratio after solving, you will be getting it to be Ti by T naught is 3 by 15. 3 by 15. Okay, and when you will be putting this, as I know you are getting tired, so I'm giving you the answer for this. After putting the values, what you will get the answer as 3 by 2. So answer will be 1.5. Okay, guys. So we have completed the questions from 2019 to 2022. And my dear, 23 questions when we are talking about, they are available on the channel with the complete paper of 2023 solution is given. And for mechanical, only one shift was there this year. So you can see that paper is available like sir have shown you in the civil. Okay. Yes. So guys, I would like to say wonderful for you guys that who stayed for the complete session. It was more than 2 hours. Sir is also there with us now.
Yes, sir. So guys, let me tell you that when you open our channel now, so in video section, okay, let me just see, this is a session running on. Serving will be 5 p.m. So then this will be at 7:30 am likha hua hai, but that will be in the evening. Okay. And that session of NIT works will be coming soon. Not soon, it will be coming again. Oh, sorry, it will be 8:30 am written because my smartboard time is some different. It is written on some different zone. Okay, so sir, SOM question will also be coming for ISRO. Now for the 2023 paper na, that is the workbooks I'm saying. Sunday ka funda is coming. Super Saturday was done by Joshi sir yesterday. Richa ma'am short trick. So daily dose, Sunday ka funda, Super Saturday, everything is done. This is also a very beautiful question of SOM. Please do attempt this. Dheeraj sir, Sunday ka funda, Richa ma'am, Sunday ka funda, Nikola Tesla video, my favorite video of mine in this channel. And for 2023 na, guys, Sunday ka funda, daily dose, Super Saturday, everything will be in this. Everything will be in this. Now for the video section, if you go, so if you go a little bit downward now, you'll be finding, we'll providing a link also. Our team will provide you the link also. Otherwise, kahan gaya mechanical? Mechanical solution of 2023 was done. Shit. Mechanical solution of 2023 was done there. Okay, you can see that. Complete paper was there. Okay, यहाँ पे चले जाना यार, मेरे से तो कुछ और दब जा रहा है बार बार।
So guys, like sir have shown you the civil paper solution of both the shifts. Mechanical solution is also there.
सर नहीं बनाया मेरे को लग रहा है आपने।
सर सिविल से पहले आया था।
कहाँ गया? तो बनाया है कि नहीं बनाया? ऐसे बच्चों का आप मजाक कर रहे हो
सर
बच्चों के
लिंक शेयर कर देंगे सर।
साथ। एग्जाम से पहले तो नहीं बना दिया?
नहीं नहीं सर।
Yeah, this is civil, है ना? Forenoon and afternoon for 23. For all subjects for 23 you can see there. And mechanical is this one. Mechanical is this one. Okay. सर हमसे ज्यादा आपके व्यूज भी हैं। हमारा 1 पॉइंट है, आपका 2 पॉइंट है। ओके ठीक है। This is the mechanical solution for 2023. You can see it there. ओके दोनों को मिला के हमारे ज्यादा है सर। 2.2 है हमारे, 1.2 और 1 आपके 2.1 है।
सर तो बच्चे भी ज्यादा थे ना। नहीं सर,
Okay.
civil students have shown wonderful dedication. Like लास्ट तक बने हुए हैं। मुझे मैकेनिकल वाले कब दिख रहे हैं अभी।
So guys, Sunday का फंडा everything will be here ना in that session. Okay sir. ठीक है सर। Okay. Okay guys. So see you now in the evening with the civil students for surveying and mechanical students for the ISRO regarding some information. Thank you. Thank you everyone. Take care. Thank you all. सर हो गया।